Hello everybody, just before we get started with today's video, I do want to tell you about our fantastic sponsor today, and that is Lumen, which is so much more than a device. This is a metabolic coach, and it can guide you towards a healthier lifestyle. Now, why does metabolic health matter? Well, think of your metabolism as your body's engine. When it's running smoothly, you feel amazing, and that's where Lumen comes in. By improving your metabolic health, you'll see benefits like easier weight management, improved energy levels, and better sleep. Using Lumen is a breeze. You turn it on, you connect it to your phone pretty much immediately. Then you just click the button to do a test. I'll choose after eating because I just had lunch. We'll do some lunch. Click next. It'll tell me to relax. Let's go.
Inhale deeply through your lumen.
Inhale deeply.
Hold your breath. Exhale in 3, 2, 1.
It'll analyze. See? Very easy. And it'll tell me, come on, burning fat. Oh, what am I doing? I'm burning 45% fats and 55% carbs. I need that to more towards fat. And it'll tell me, if you go next, it'll give you a customized diet plan. So it says eat more vegetables, non-starchy vegetables. And I'm like, yes, Lumen, that would get me more towards the fat burn, wouldn't it? Which would be nice. We'll get there together. You could track your progress and improvements over time. Plus, with over 55 million metabolic measurements logged, you know you're in good hands with Lumen. So if you're ready to level up your health game, why not give Lumen a try? All you need to do to get your free metabolic health score is go to go.lumen.me/brainfood, or just click the link below and you'll get $100 off Lumen as well. So click the link below, get $100 off, and start improving your health today. And now back to today's video.
Given the public nudity is generally considered unacceptable in most of the modern world, and if you're wondering, do see our video on when did humans start wearing clothes for more on that subject, people have long tried to come up with other potential indicators to determine the size of a guy's manhood without actually seeing it. A seemingly tried and true method for doing this is just to look at the size of the man's hands or their feet. But does hand and foot size actually correlate to the length of the penis? The short answer is no, it doesn't. Studies have consistently shown that the size of a guy's feet or the overall size of their hands is not related to their member's erect measurements. However, a man's fingers do give a strong clue as to their probable penis size, but the overall length of the fingers is not what's important here. For instance, a study published by the Asian Journal of Andrology in 2011 found that the ratio between the second and fourth digits on the hand strongly correlates with the overall length of an individual's penis. Specifically, Dr. Ho Choi et al. State, univariate and multivariate analysis using linear regression models showed that only digit ratio was a significant predictive factor for stretched penile length. In a nutshell, the lower the ratio, how much shorter the index finger is than the ring finger, the longer the penis would probably be when erect. And if you're wondering, flaccid penis length is not an accurate predictor of erect penis length. More specifically, you can calculate your ratio by taking the length of your index finger, measured from the crease where it meets your hand to the tip, and divide it by the length of your ring finger. The shorter your index finger is compared to the ring finger, the lower the ratio will be, and if you're a man, the longer your penis probably is. Though, of course, there are exceptions, as with everything. So, does the ratio of the index and ring finger lengths correlate to erect penis length? Well, in the beginning, female and male genitals are pretty much the same. This is because they develop from the same cluster of tissues called gonads. In males, somewhere around 7 to 9 weeks of gestation, the gonads begin secreting two hormones. The first is anti-Mullerian hormone, AMH, and testosterone. AMH prevents the development of the ducts that eventually turn into the fallopian tubes, the uterus, and the upper vagina. Once the gonads begin secreting testosterone, some of it, around 5 to 10%, gets transformed into another hormone called dihydrotestosterone. Both testosterone and dihydrotestosterone will attach to androgen receptors, which affect the growth and development of many different human body systems. Notable here, dihydrotestosterone testosterone attaches to androgen receptors on tissues that eventually develop and combine into the penis and scrotum. Lower levels of this within the womb or later during puberty may result in underdeveloped or a malformed penis. So to sum it up here, penile growth in the womb is stimulated and affected by testosterone, dihydrotestosterone, and androgen receptors. Circulating amounts of the two hormones combined with the associated androgen receptor stimulation will determine penis size. So now what about the fingers? Circulating testosterone in the womb will affect other body parts as well. Pertinent to the topic at hand, this includes the ratio between the second and fourth digits, the index and ring fingers. So why does testosterone affect different digits differently? For that, we'll have to get a little more technical, but essentially the activity mediated by androgen receptors and estrogen receptor A is higher in your ring finger compared to your index finger. This is regulated by the structure of genes controlling the process for the bone growth of your fingers, called endochondral ossification. The spread of chondrocytes will determine the length of your finger, and this expansion is higher in the ring finger compared to the index finger. When you decrease the activation of androgen receptors during the narrow window of digit development, usually completed by week 13 of gestation, you will decrease the length of your ring finger. This activation is attributed to the amount of testosterone and DHT circulating through the tiny fetus. Conversely, if you decrease the activity of the receptor estrogen A, the ones being stimulated more when you're female, you will get a longer ring finger. Based on this physiology, it has been long known that you can predict prenatal hormone exposure based on the ratio of these two fingers. Since both penile length and the ratio of ring and index finger is basically a result of the amount of testosterone and DHT circulating in utero, there is a correlation between that ratio and the length of a man's favorite appendage. So, as you might have guessed from all of this, the ratio between the length of one's index and ring fingers is usually quite different in men and women. Men tend to have shorter index fingers than ring fingers. Women tend to have their index fingers either the same length or longer than their ring fingers. And now for a bonus fact. Penile length isn't the only thing digit ratio can somewhat predict. Since testosterone and DHT control the development of several body systems and processes, digit ratio can be a predictor of a wide range of physiological and psychological conditions. These include things like athletic ability, sexual orientation, fertility, and some sex-based ailments such as prostate and uterine problems. Lower digit ratios tend to occur in those with more aggressive behaviors, and those with them are less likely to suffer from eating disorders. People with higher digit ratios tend to be more agreeable. Studies have also indicated that straight women and gay men who have higher ratios tend to prefer partners who are more masculine.
There are several different types of blood. Contained within them are different types of cells and countless molecules that give our bodies the needed nutrients to work effectively. The two main types of cells within the blood are red and white blood cells. Red blood cells make up nearly 45% of your blood volume. White blood cells make up less than 1%. So, what's left over? There's obviously a giant gap there, and well, that would be blood plasma, which makes up approximately 55% of your blood volume. As to blood types, what type you are will usually depend on the types of blood your parents have, though there can be exceptions, like if you receive a bone marrow transplant from someone with a different blood type, your blood type will eventually change, among other certain caveats like that. As to why there are different blood types, well, this isn't actually fully understood, though it's been observed that different blood types play a role in your susceptibility, or lack thereof, to certain diseases and conditions. For example, malaria seems to have been a major contributor to type O blood being a major thing in places like Africa, where about 51% of the populace have type O blood. As to why, it turns out for various reasons, type O blood will generally mean you won't get as sick if you get malaria, so that's a good thing. So, what are all the other blood types? And what's the whole positive and negative thingy about? Okay, so basically there are 8 main types of blood, and they're separated into 4 groups, with over 90% of people falling into one of these main groups. The groups are A, B, AB, and O. If you're wondering why O and not, for example, C to make it ABC and nice and easy, well, it turns out that it was originally called C, but then it was later changed to the letter O in some regions or the number 0 in others. In both cases, this was to signify 0 or null, for reasons that we'll get into in a second. It wasn't just random. In any event, these blood types are grouped together by the presence or absence of what is known as an antigen. Antigens are the substances within the blood that basically cause our immune systems to create antibodies, which are essentially used to recognize invaders. These created antibodies then send anything the immune system thinks is a threat to sleep with the fishes. The specific antigens that create the different blood types are found on the surface of red blood cells and are known as type A and type B. They're further separated by the presence of another type of antigen known as Rh factor. If you have this Rh antigen present, you're considered a positive. If not, you're considered a negative Nancy, and nobody likes you. We're looking at you, Jimmy. Someone that has type A antigens and Rh factor is considered to have type A plus blood, the best grade of blood. And if you have both types of antigens and no Rh factor, then you have type AB negative blood. If you have no A or B antigens, then you are type O blood, hence the whole zero or null thing that was mentioned before. All of this matters because of those antibodies that your immune system creates. Someone with type A blood will at some point in their earliest months or years, for trigger reasons not really wholly understood, they'll develop antibodies for type B, and somebody with type B blood will have antibodies for type A. Type O has antibodies for both A and B. Okay, so let's actually answer the question of the video, shall we? This all brings us around to why mixing and matching certain, but not all, blood types in a person is a really bad idea. In a nutshell, if you were to give type B blood to someone who is type A, their antibodies for type A would attack the type A red blood cells, causing unwanted side effects, including, in the extreme, various things like kidney failure, as your kidneys try to filter out all of the destroyed red blood cells. It's not going to be a good time. And of course, regardless of this sort of thing, as you need sufficient blood to keep living, if your immune system destroys a high enough percentage of what you currently have in your body, well, it's not going to be a good time for you. But it's not always a bad idea to mix and match. For example, disregarding a bit of a caveat about atypical antibodies and things like that, someone with AB positive blood can actually receive blood from every other main blood type. As to why, if you've been following along, this is because these individuals are characterized by having both A and B antigens on their red blood cells, and thus cannot have either antibody in their plasma. For this reason, those with AB positive blood type are sometimes referred to as universal recipients because they can accept blood from anyone, again with the caveat about those atypical antibodies. However, the downside of this is that because of the presence of both antigens on type AB red blood cells, people with AB positive blood can only donate blood to others with the same type, and AB negative are only able to donate to AB positive or AB negative individuals, but are able to receive from any of the negative blood types, again with the aforementioned caveats, which we're just going to stop saying, but realize that it's a thing because the universe apparently hates simplicity. However, while AB blood type individuals can only donate blood to the same type, the reverse is true of plasma donations for them. This is because, again, AB individuals have neither A or B antibodies in their plasma, thus they are universal plasma donors. On the other end of the spectrum, type O, as noted, has neither A or B antigens on its red blood cells, but both A and B antibodies in its plasma. As a result, those with type O negative may donate to a person with every blood type but can only receive O negative blood since its plasma antibodies would attack anything else. This is why, along with the fact that only 7% of humans are O negative, those with the O negative persuasion are highly encouraged to donate blood often, first potentially for themselves, which is particularly handy to do regardless of blood type. If you know you have a major surgery coming up, this gets around any shortage issue, as well as gets around any of the aforementioned potential compatibility caveats. The second reason O-negative individuals are encouraged to donate often is, of course, because this can benefit most everyone. This is particularly the case when, in an emergency, there may not be time to figure out what blood type a person is, and thus if O-negative is on hand, that can be reasonably safely used immediately, if absolutely necessary. Now, if you're wondering about the full list of main blood types and plasma compatibilities, we have these two charts where you'll note that they are more or less inverses of one another in terms of compatibilities between donor and recipient, for reasons previously explained. Moving on to white blood cells, there are 6 main types of white blood cells. They are neutrophils, neutrophils, eosinophils, basophils, bands, monocytes, and lymphocytes. Each type plays a different role in the kind of infection your body is trying to fight. For example, neutrophils kill bacteria by ingesting them, called phagocytosis. Naturally, if you have a bacterial infection, the percentage of neutrophils within your blood would be elevated. On this note, in the general case, white blood cells number approximately 4 to 10,000 per microliter of blood. If their number is increased, then you probably have an infection that your body is trying to fight and you're going to drop dead, well, any time now. Go ahead, we'll wait. Just be sure to click on autoplay. You dead yet, Jimmy? Excellent. As you might expect from this, when a doctor draws your blood to find out what's wrong with you, it's these high levels of white blood cells that will help them narrow down the cause of your problem. The last part of blood is the aforementioned plasma. This makes up most of your blood volume, and about 90% of plasma is simply water, with another 8% of plasma made up of proteins such as albumin, which helps move molecules like calcium and medications through your blood. It also helps move antibodies that help fight infection, and fibrogen and clotting factors that help with the clotting of your blood, obviously. If you've been following the maths here, there's 2% left, and that contains hormones like insulin, electrolytes like sodium and potassium, and nutrients like sugars and vitamins. And just before we finish up here, one little tip from the paramedic author of this particular piece: how do you get blood stains out of clothes? I guess that was more useful for you, Scott. If you spill or otherwise get blood on your spilling blood, dude, whoops. If you spill or otherwise get blood on your clothes when Jimmy takes too long to dye on his own, just soak it in 1 quart warm water, 2 teaspoons of laundry detergent, and 1 tablespoon of ammonia for approximately 15 minutes. Then remove all the ammonia and launder it normally. Are we creating a guide for how to clean up blood? And note, don't dry it until the stain is completely gone. Bam, your clothes will be blood-free, and the cops will never be able to link Jimmy's death to you. I don't want to speculate about my murdering, but I'd definitely burn my clothes. It's like, oh yeah, well, I washed them real good. I'd be like, I'm pretty sure science is quite good. Maybe, I don't know. Burn those clothes. Bonus facts. Speaking of blood, a commonly touted idea is that deoxygenated blood turns blue. It turns out, however, this isn't true at all. The misconception that blood that lacks oxygen turns blue probably comes from the fact that veins appear blue and blood in the veins is typically heading back to the lungs. Hence, it would be depleted of oxygen and people are like, oh yeah, it's blue, okay. It's also possibly from the fact that when people are suffocating or the like, their lips and complexion seem to turn bluish or purple. As to why veins often appear blue in those of the fairer-skinned persuasion, this simply has to do with the fact that they are very close to the surface of the skin, combined with the way that light diffuses in the skin of certain shades. More specifically, veins may appear blue in some people from the way subcutaneous fat absorbs low-frequency light. This permits only high-frequency blue and violet wavelengths to penetrate through the skin to the vein. Wow, that's complicated. With the other wavelengths getting filtered off from the pigmentation of your skin. In fact, when skin is removed, God, such as when dissecting a cadaver or when you're giving Jimmy what he deserves. Who is Jimmy? Poor Jimmy. Oh, the veins and arteries actually are a somewhat similar color. A smaller light diffusion process is happening when we see people who are suffocating and have purple lips and fingertips. In this case, the blood is so oxygen deprived that it turns an extremely dark shade of red. When the light diffuses through the skin of the lips or through your fingernails, it then often ends up looking very dark blue or purple. In reality, of course, blood is, shockingly, various shades of red, with the red color primarily coming from hemoglobin, which contains 4 heme groups. These heme groups' interactions with various molecules end up giving it the dark red or light red color that we see, usually with some caveats like carbon monoxide poisoning being lighter red when particularly oxygenated and darker red when it has less oxygen. There are some creatures that have blue blood, rich people. For example, horseshoe crabs, whose baby blue blood is actually worth about $60,000 per gallon. Damn! This is due to a chemical found in the amoebocytes. A-M-O-E-B-O-C-Y. Amoebocytes. Amoebocytes. Amoebocytes.
Amoebocyte.
Nailed it. This is due to a chemical found in the amoebocytes of its blood. When this is exposed to a potentially dangerous foreign bacterium, it will immediately coagulate around the threat, rendering it harmless without actually destroying it. This effect is near instant, and the blood can be used to detect a potential threat, even if it's diluted as much as 1 part per trillion. This effect is amazingly useful for detecting bacterial contamination in things like medicines and vaccines, or on medical equipment like needles, pacemakers, and numerous other items that are required to be sterile. In fact, no drug on the market today can be certified by the FDA unless it has been tested using this exact method, known as the Limulus amoebocyte lysate test. This was in homage to the species of crab, Limulus polyphemus. It's by far the best way scientists are aware of for detecting whether a batch of medicine or vaccine has been compromised or not. As such, the blood of these crabs is worth a small fortune, selling for around $60,000 per gallon. If you're wondering how this blood is harvested, the crabs, I wasn't, but okay. I assumed you just killed the crabs. If you're wondering how this blood is harvested, the crabs, over 500,000 per year, are carefully picked up when they visit the shore for breeding purposes and taken in cooled trucks to certified labs where around 30% of their blood is drained, after which they're returned to the sea. Oh, that's nice. The blood cells are then separated using centrifugation. Next, the isolated cells are placed in distilled water where they will eventually burst, releasing the valuable chemical inside. After being purified, it is then freeze-dried and stored to be used for testing. Approximately 85 to 97% of the crabs harvested for this purpose survive and go on their merry way afterwards, with the crabs' blood levels returning to normal in under a week. Even with the relatively good survival rates, all of this may sound a little harsh. I don't know. We kill and eat animals every day. I'm not super worried. I've eaten loads of crabs. But there is one type of animal besides humans that at the least is glad this property of horseshoe crab blood was discovered in 1956 by Dr. Frederick Bang, namely the rabbit. Before the horseshoe crab blood method, LAL, of detecting microbial contaminants, a much less accurate and time-consuming system involving testing on live rabbits was used. In this rabbit pyrogen test, the rabbits were injected with a sample of the substance to be tested, so it was a bad time for them. If you've spent virtually any time on the interwebs, and particularly lurked in the social media areas of this marvel of human ingenuity, you'll no doubt at one point or another have come across the fact that many women have living male cells hanging out in their bodies, including in their brains. The most common explanation, according to social media, for how these instances of microchimerism came to be is that women acquire these cells via making the beast with two backs with a man. The claim that often follows this is that, given these cells and their replicates have been shown to sometimes hang around for decades in the woman, that most women have the DNA of every male sexual partner they've ever had in their bodies. But is any of this actually true? As with the vast majority of quick facts spread around on social media, there are elements of truth to it, but the part that makes the fact spread does not appear to be true at all, based on the current state of scientific research. Unlike the effect of having unprotected social media, which will always leave residual undesired things in your brain, having sex with a guy doesn't seem to be a contributor, or at least not a major contributor, to male cell lines finding their way into women's bodies and brains. So how do these cells get there, and where did the rumor that women retain the DNA of every man they've ever slept with start? To begin with, back in 2012, a study titled Male Microchimerism noted that after dissecting a number of deceased women's brains, 63% of the brains, 37 out of 59, had male microchimerism present. While it was touted by many a media source that this was a huge discovery, in fact, it has long been known that a large percentage of women eventually carry living male cell lines in their bodies. For example, a study in 1969 published in The Lancet showed that 70%, 21 out of 30 pregnant women, 19 of whom were pregnant with boys and 2 others having previously had boys, were found to have male microchimerism. From there, countless other studies have shown the same thing, including some animal studies that showed some of these cell lines are able to cross the blood-brain barrier in mice. What made this particular 2012 study so interesting was simply that it was the first to show that these cell lines could cross the blood-brain barrier in humans as well. It's also interesting to note from this study that 33 of the women had Alzheimer's, and that these women had lower likelihood of having male microchimerism present. And even those who had Alzheimer's and male microchimerism, they tended to have lower concentrations of these cells. More on this and the potential benefits and drawbacks of microchimerism in the bonus facts section, which we'll get into in a bit. In any event, noteworthy here is that despite explicitly stating the likely sources of these cell lines, mostly centered around pregnancy, at no point in the study did the researchers state that these came from former sexual partners. And as for the pregnancy source, the researchers speculated this may be how the cell lines are getting past the blood-brain barrier in the first place. They state, changes in BBB permeability occur during pregnancy and may therefore provide a unique opportunity for the establishment of microchimerism in the brain. So, how did this study become the source of the myth that women retain the DNA of every sexual partner that they've ever had? Enter Baxter Dimitri, a man who has the personal tagline, speaking truth to power since he learned to talk, and noting that he's traveled in over 80 countries and won arguments in every single one. Naturally, a person who speaks such truth would write on a website, Your Newswire, that itself had the tagline, News, Truth, Unfiltered. With all that advocating for truth, it should come as no surprise that in June of 2017, Baxter published a completely unbiased and truthful piece on Your Newswire titled Women Absorb and Retain DNA from Every Man They Have Sex With, using a study that literally said none of this as his primary source for that belief. As for how he got around this little problem of the researchers not even hypothesizing about this, using his masterful debating skills famed in 80 countries the world over, Baxter states of the researchers' actual suggested sources of this male DNA, researchers assumed that the most likely answer was that all male DNA found living in the female brain came from a male pregnancy. That was the safe, politically correct assumption. But these researchers were living in denial. The scientists didn't know what the hell was going on. Confused, they did their best to hide the evidence until they could understand and explain it. They buried it in numerous sub-studies and articles. But if you sift through them all, you will find the damning statement, the one line that gives the game away. This one line that gives the game away is a 2005 study, Male Microchimerism in Women Without Sons. In this study, they found that 21% of the 120 women they looked at had male microchimerism. Of these women, 26 of them had daughters, 23 had spontaneous abortions, 23 of them had induced abortions, and 48 of them had never been pregnant that the women were aware of. The results were the first group, who only had daughters, had an 8% rate of male microchimerism. The second group with spontaneous abortions had a rate of 22%, the third group with induced abortions had a rate of 57%, and the final group, who'd never been pregnant, were at just 10%. It was similar to the group who'd only had daughters. So how does this support Baxter's claim? In his study, along with mentioning the more likely origins of this microchimerism, they also hypothesize that it may be possible some of these cases could be from having sexual partners of the male persuasion. They offer no supporting evidence of this, simply speculating for potential further research. From that one, then unstudied hypothesis presented in the paper as the least likely possibility and completely dismissing the many other studies on the subject, Baxter naturally gave the unfiltered truth that this proved women retain the DNA from not just some, but every single man they've ever had sex with. He also, for some reason, stated that the researchers of the 2012 study were trying to hide this fact from the world. We guess for, well, reasons? He also made another, lesser talked about, we'll say, interesting claim that we'll get to shortly. But before that, as for the main claim, given this information as a grain of truth, is claimed to be backed by a scientific study, which few are going to bother to read, is mildly plausible on the surface, or at least not readily debunkable by the layman without looking into it a little, and is incredibly eye-catching in headline form, it naturally spread throughout the various social media outlets whose algorithms and platforms cater to content with no depth or nuance, like Facebook or Twitter. Now, you'd think that's where it would end, given this particular little fact, using the 2012 study as its supposed source takes only about 10 minutes to call its accuracy into question via even just skimming the cited study. But it turns out a large percentage of popular general news sites don't actually bother to have their authors read the studies they're reporting on, with this little rumor functioning as a great test to see which outlets do and which outlets do not. And so it was that many of the most popular general news outlets reported that the researchers in the study claimed the source of DNA in women's brains was from sexual partners. Some of the worst offenders even doubled down and went with the full supposed fact that the study showed women retained the DNA of many or all of their previous sexual partners. This finally brings us to where the DNA is actually coming from. As briefly alluded to, pregnancy seems to be the number one source, though it turns out it doesn't necessarily need to be the pregnancy of the woman in question. Because these cell lines from the fetus can survive for decades after the pregnancy, subsequent pregnancies a given woman has can then see some of these cell lines find their way into the new little. Demonstrating this cellular exchange, directly after pregnancy, approximately 2/3 of women will carry fetal immune cell lines, for example. On the flip side, about 1/3 of the time the baby will have the maternal immune cells after they are born. Illustrating all this, we have such research as a 2015 study, microchimerism of male origin, in a cohort of Danish girls looking at 154 girls 10 to 15 years old. Unfortunately, for adding a more definitive data point to the question at hand, the researcher did not ask the girls if they'd had sex before, though given their age, it can be presumed that the majority had not. Delving into this, the researchers note that in a separate study, it was shown that approximately 16% of 14-year-old girls in Denmark have had sex, and a total of 36% have done so by the age of 15. Importantly, however, 80% of these 14 to 15-year-old girls who had sex reported their partner used a condom, which limits the possibility of such cell transfer. In any event, the results of this study on 10 to 15-year-old girls showed that 13.6% of the girls tested positive for male microchimerism, which is more or less in line with the previously mentioned study of adult women who'd either only had daughters or never been pregnant, with rates of about 8 and 10% respectively. This also almost exactly lined up with another study on prepubescent girls, with about 14% testing positive for male microchimerism in that study. As other studies have also shown, the 2015 study researchers also noted that girls who had older brothers were more likely to test positive for male microchimerism, with more older brothers the more likely to test positive. They also found girls whose mothers had blood transfusions during pregnancy were more likely to test positive as well. Given this dataset, however, the researchers do note that they could not account for all the instances of male microchimerism based on the known data, and thus further research is needed to figure out where all these cell lines are coming from more definitively. To date, it isn't actually fully clear what is happening here for these unaccounted for cases. The leading hypothesis is that these are probably coming from things like cases of a vanished and unobserved male twin, or more likely in most cases, a woman, including the mothers of these girls, having been previously pregnant with a boy and they simply didn't know it. It turns out, depending on what study you want to go with, between 1/3 and just under 1/2 of all human pregnancies result in a miscarriage, with a decent percentage of these happening without the woman actually knowing she was briefly pregnant. Further, a large percentage of the rest of these miscarriages happen before the sex of the baby is known. That said, given researchers have not yet definitively been able to account for all these sources of male microchimerism, it's always possible it could be from a sexual partner, and more research is needed to figure this out definitively. But at present, this is deemed unlikely. But why? Well, it turns out it's a massive conspiracy backed by the lizard people. Or for those of you who want to continue to allow our lizard overlords to pull the wool over our eyes when talking the every partner narrative, this can conclusively be shown to be false, with the known data given that if that was true, virtually every heterosexual woman should test positive for male microchimerism. This is not the case. But even when just looking at unprotected sexual partners, where there is indeed some brief surface-level cellular exchange happening for both partners, most researchers still find this an unlikely source, as the vagina is an incredibly inhospitable place to try and establish a cell line in the first place, including being relatively rapidly self-cleaning and good at getting rid of such offending cells. And even if some cells still manage to find their way into the bloodstream via, say, cuts in the vagina or things like that, these would, in the vast majority of cases, be identified and eliminated by the woman's immune system. Fetal cells, on the other hand, can potentially have ways around this problem. As summed up by Dr. J. Lee Nelson, co-author of the aforementioned 2012 study that is the commonly cited source of this myth, any suggestion that male DNA is routinely retained from sexual partners has no support from any scientific study. The biggest statement is the data. If this were routinely happening, you would see it in the vast majority of adult women without sons that we studied. We should probably also address very briefly that some have very bizarrely gone further and claimed that it's the sperm themselves that manage to survive and live on in the women. But of course, sperm don't replicate themselves and only last at most a week or so. So, well, just no. As to how that rumor got started, well, that was in Baxter's original piece that started the main rumor in the first place. To quote the legendary debater, "Sperm is alive. It is living cells. When it is injected into you, it swims and swims until it crashes headlong into a wall, and then it attaches and burrows into your flesh. If it's in your mouth, it swims and climbs into your nasal passages, inner ear and behind your eyes. Then it digs in. It enters your bloodstream and collects in your brain and spine. Like something out of a sci-fi movie, it becomes a part of you, and you can't get rid of it." What? Given that this part is easily debunkable without any research needed by the vast majority of even high school educated humans, it goes to show you that the over 70,000 people who shared his post on the subject didn't even bother to read the source of the fact before they shared it. Now, all of this said, if you twist the wording of the headline, "Women retain the DNA of the men they sleep with" enough, you could say that a man who got a woman pregnant does have a part of his DNA surviving in her, thanks to the joined genes from the sperm and egg, then producing a fetus that then spreads certain of its cells in the woman, some of which survive long term. But at least when talking about the common full headline, "Women retain the DNA of every man they've ever slept with," this is conclusively false, even when talking about having sex without a condom. And while research may someday show this can potentially happen in some very isolated cases, though again, among other factors, the women's immune system makes this implausible, the body of evidence to date definitively shows that it can't be common, else by the twilight years of most heterosexual women's lives, there would be an almost 100% rate of male microchimerism, even in women who'd never had older brothers nor been pregnant with boys themselves. Thus, as ever, when having unprotected social media, always remember the wise words of the great Wheezy Waiter in his sage song,
"A headline's not an article, a tweet is not an article, it's basically a particle of a full-blown pooped-out article."
And now for a bonus fact. Speaking of the potential health benefits and drawbacks of these fetus-sourced cellular lines hanging around in women's bodies, women with lupus erythematosus that also have male fetal cell lines in their bodies have been shown to have consistently better functioning renal systems versus those women without these male fetal cells. This and many other studies seem to indicate in some cases these fetal cell lines might actually help in repairing damage to certain body parts. Similarly, it's long been known that pregnancy ultimately reduces a woman's chance of both getting and dying of breast cancer. Why isn't clear, but relatively recent research has shown that certain fetal cell lines concentrate in this breast tumor tissue, with it being hypothesized that this may be having a positive effect. Other studies have similarly shown a potential benefit to fetal cell lines to women who later develop certain other types of cancers with similar congregation of the fetal cells in the tumors. Again, with all of this though, how this is helping, if at all, isn't fully clear, and in some cases it's been speculated to actually increase the chance of getting certain cancers. Obviously, much more research is needed to determine any of this definitively. Also, on the flip side, the effects of these cell lines in a woman's brain have been proposed as a possible reason women are more susceptible to certain neurological disorders. Likewise, these cell lines have been speculated to be increasing the chances of certain autoimmune disorders that women are more susceptible to. That said, there is one neurological disorder mentioned in the aforementioned 2012 study, and also in several others, where the presence and high concentration of fetal microchimerism chimerism seems to strongly correlate to less chance of developing the disorder, that being Alzheimer's. Though again, as with pretty much everything to do with this field of study right now, significantly more research is needed to determine anything definitive. A commonly touted notion is that your hair will grow faster, be thicker, and otherwise naturally longer in the wintertime thanks to the supposed evolutionary benefits to help keep you warm in the colder months. But is this actually true? And what about beards? As to the former, yes and no. As to the latter, it turns out something more interesting is going on with beard growth cycles, so let's just jump into it, shall we? First, it's important to understand how hair growth cycles actually work. Hair length is completely controlled by the length of the anagen phase of your hair follicle. So, how long this period lasts is generally determined mostly by genetics and hormones, with factors like extreme stress, nutrition, and activity levels influencing the latter. Following the anagen phase is the catagen phase. It isn't yet fully understood all the factors that go into triggering the catagen phase, but once it is triggered, the outer part of the root ends up being cut off from its nutrient supply, blood, as well as the cells that produce new hair, thus your hair stops growing. The phase lasts about 3 weeks. Next up comes the telogen phase, where the follicle is in a resting state and your hair is now a club hair, completely dead down to the root. During this stage, these hairs are relatively easy to pull out, as can happen while brushing, combing, or washing your hair. But if they manage to last long enough, they'll eventually be pushed out by a new hair as the cycle begins again. Obviously, hairs on your arms and legs have a very different anagen period than the hairs on your scalp, thus why your leg hair doesn't grow 2 feet long without trimming. Further, different people, thanks mostly to their genetics, have differing lengths of the anagen period for a given body part compared to other people. For the hair on your scalp, the average length of this anagen phase is about 2 to 7 years. For your arms, legs, eyebrows, etc., this phase usually lasts just 30 to 45 days. However, in extreme cases, which are quite rare, some people have anagen periods for their scalp hair as small as most people's anagen phases for their arms and legs. For these people, their scalp hair never naturally grows more than a few inches long. The opposite is also true with very rare individuals whose anagen phase can last decades for their scalp hair. At any given time, about 85 to 90% of your hair is in the anagen phase, 1 to 2% is in the catagen phase, and 10 to 14% is in the telogen phase. However, extreme stress can trigger the anagen phase to stop prematurely, and hair can rapidly progress to the telogen phase, even as much as 70% of the hair on your body at once. When this happens, the majority of your hair that should still be growing can fall out more or less all at the same time. This all brings us around to seasons and what effect this has on your hair. It turns out studies have shown that while your overall growth rate of much of the hair on your body doesn't change significantly from month to month, there is a difference in density thanks to the peak percentage of hairs in the anagen growth phase in certain months and peak percentage of hairs in the telogen dead falling out phase during other months. For example, a study seasonality of hair shedding in healthy women complaining of hair loss looked at 823 women over 6 years and noted a marked and relatively consistent trend of periodic shedding, with peak density of hairs in the telogen falling out phase in the summer and another small spike in the spring as the weather starts to warm. The lowest rates, and thus the highest rates of the anagen growth phase, were in the winter, maximizing the density of hairs on your body. That said, the differences here are relatively slight, as we'll get into shortly, so this isn't likely to actually make any real difference in keeping humans warmer or not, even if one were to simply let their hair grow out for maximal insulation. But what about beards? You may or may not be surprised to learn that this is an area that very few researchers have thrown their brainpower at. Thus, while we couldn't find any data on the density of beard hairs in anagen, catagen, telogen phase by season, there does exist one study tracking beard hair growth rates by month that reveals something rather interesting. It turns out the data so far seems to pretty strongly indicate that beard growth is actually maximized not in the winter, but the summer. This actually makes sense when you look at the underlying mechanisms behind beard hair growth and its hypothesized connection to mating, the latter of which we'll get into in the bonus facts in a bit. But first, the study, Seasonal Changes in Human Hair Growth, published in 1991, looks at a group of British men aged 18 to 39, tracking their beard growth and activities for 18 months. In the study, the researchers also confirmed what others have likewise shown, that scalp hair, for example, has a peak amount of hair in the anagen growth phase in the winter. In their study, they observed that peak anagen phase around February and March at approximately 90%, then falling steadily from there until September, then climbing back up again. They also directly measured about 60 hairs lost per day from the scalp at peak telogen phase time in the summer, and about half that rate in the winter. As for beards, they observed that the growth rate of beard hair actually peaked in June and July and was at its lowest in January and February. Not a subtle difference, the peak growth rate in the summer months was 38% faster than in the lowest growth rate months of January and February. Bizarrely, the rate of growth in these men's thigh hair more or less mimics the general growth cycle of the beard hair, albeit without as much of a contrast between the lowest growth rate months and the highest. Now, one important thing to note is that there has been very little research done on the rate of beard hair growth. For example, this study only had 14 men in their sample and they all had indoor jobs. This is potentially significant given what is hypothesized to be causing the difference. If the hypothesis is correct, men who, say, live in Southern California and work outdoor jobs may see little variance in beard hair growth from season to season. So, well, what's thought to be causing the change? First, the researchers noted that the men were significantly more active in the summer and spent more time outdoors. It is hypothesized from this that the increased activity outside results in things like more exposure to sunlight and a boost in vitamin D, a change in melatonin secretion, which in turn affects prolactin secretion, along with various other hormonal changes that follow from all of that, including a slight boost in testosterone. These all seem to play their parts in seasonal changes observed in our hair, both in the very slight cycles in seasonal shedding and particularly in the case of testosterone, change in growth rate of the beard. So how does testosterone do this? It turns out not directly. The extra testosterone ends up resulting in the creation of a much more potent sex hormone called dihydrotestosterone, DHT, with the enzyme 5A reductase facilitating the conversion of testosterone to this, including the conversion happening in hair follicles. From there, different hair follicles on your body react differently to DHT. Pertinent to the topic at hand, DHT seems to be a major factor in male pattern baldness, more on that in a bit. On the other hand, the hair follicles in your face end up getting stimulated by DHT, causing an increase in hair growth rate. Thus, more testosterone means more DHT stimulating your facial hair growth, and thus, in the summer, when you're more active and the like, your beard grows faster. Or at least, that's the working hypothesis at the moment. Again, beards are not exactly something many scientists are earning their PhDs writing research projects on. But at least the data at hand does seem to be leaning that way. Now, noteworthy here, contrary to popular belief, is that men with thick flowing beards do not necessarily have more testosterone than their patchy or naturally barefaced brethren. As dermatologist Dr. Jennifer Schwalek states, men who can't grow a beard or have patchy beards usually have normal testosterone levels. It isn't a reflection of having low testosterone or being deficient in testosterone. It turns out, while there are certainly many exceptions, most men of a given age and general fitness, nutrition level, and the like have in the ballpark of the same amount of testosterone as their compatriots with the same fitness level, age, etc. Thus, the difference in beard hair growth usually isn't so much about a significant difference in testosterone. If it was, you'd not have so many elderly men with long flowing beards, for example. Rather, it more comes down to genetics and in turn the results of that, like the density of hair follicles on your face and the sensitivity to DHT in the first place, which can vary considerably from man to man. Dr. Schwalek sums up, some men have more hair follicles so they can grow denser, coarser beards than others. Testosterone gets converted in the hair follicle to a more potent form called dihydrotestosterone. Some hair follicles have receptors on them that are very sensitive to this higher form of testosterone, dihydrotestosterone, and that will stimulate hair growth. Thus, men whose facial hairs are like the drama queens of hair follicles, super sensitive, they end up producing magnificent beards when combined with a high density of hairs. This brings us to the question of why bald men seem to be able to grow the best beards. While we could find no scientific study done on whether bald men actually do grow thicker and longer beards than their hairy scalped compatriots, the perception certainly exists, and there may be something to it. As alluded to, an interesting thing about DHT is that it seems to be a major contributor to male pattern baldness, with scalp hair reacting differently to it than facial hair. But if the extra sensitivity is there for both facial and scalp hair, in one case it may result in an increased likelihood of the man going bald, while in the other case it may result in a magnificent beard. Though again, we couldn't actually find anyone who's done a study on this, but it seems a reasonable hypothesis given the data at hand, with further research needed to determine things definitively. And today's bonus fact. While we could find no study looking at pubic hair growth by season, it's noteworthy that other studies have indicated DHT has a similar effect on pubic hair as facial and thigh hair, meaning it could be hypothesized that there may be a seasonal growth rate change in one's nether regions mimicking the acceleration of beard growth in the summer. Given other studies have shown sperm count, semen volume, and sperm mobility also peaks in the summer for many men, and it's hypothesized that pubic hair has remained on humans, along with armpit hair, to help attract the opposite sex via certain pheromones, it would also make sense here. For more details about this, see our video, Why Do We Still Have Pubic and Armpit Hair? Further, beards have likewise been connected to mating via a surprising number of studies looking into the connection with beards and attractiveness. On this, studies have pretty consistently shown that women en masse find men with stubble to short beards the most attractive. However, there is another element that may favor men with long, full beards in terms of actual desire to mate with said man. For example, in the 2013 study, The Role of Facial Hair in Women's Perceptions of Men's Attractiveness, Health, Masculinity, and Parenting Abilities, the researchers found that while the majority of women perceive men with long, thick beards as more masculine than men with closely trimmed beards or clean-shaven, when women are most fertile in their cycle, their ratings of the masculinity of men with full beards increased even more. Further, the women in the study also consistently rated men with long, full beards as more likely to be better fathers and more socially mature. As the researchers sum up of their research, this suggests that an intermediate level of beardedness is most attractive, while full-bearded men may be perceived as better fathers who could protect and invest in offspring. Further, this and other studies have likewise shown that women consistently rated bearded men of all levels as healthier than their bald-faced compatriots, thus all combining to potentially give a benefit to faster beard growth at times when male sperm counts and motility are the highest, the warmer months when historically resources for baby making are at their peak. Finally, to debunk a myth, as you might have now guessed from the fact that hair growth is completely controlled by what's going on under the surface within your hair follicle, and that genetics and hormones are the primary things determining hair growth length and rate, which are in no way affected by shaving, contrary to popular belief, shaving does not in any way alter your hair growth rate, nor does it alter the color of the hair nor thickness. Study after study has shown this, and it just makes sense when you understand the mechanisms behind hair growth. There is one exception to this, and that's waxing. With waxing, it is possible to affect the thickness and other aspects of hair regrowth. However, it will never be the case that the hair will grow back thicker, darker, or faster. It actually goes the other way. With waxing, you are damaging the hair follicles underneath the skin. Over time, as you wax more and more, the hair will grow back less and less, and even sometimes will get lighter colored and thinner. So, though waxing, unlike shaving, actually does affect your hair growth, it more or less affects it in the opposite way most people think shaving does. Illustrating this in a rather humorous way, in the film The Reader from 2008, actress Kate Winslet was having a bit of trouble growing out her pubic hair to the satisfaction of the filmmakers, owing to, as she put it, years of waxing. So they had a merkin, a vagina wig, made to cover the area instead. Winslet, however, didn't care for the thing, and stated in an interview she told them, "Guys, I'm gonna have to draw the line at a pubic wig, but you can shoot my own snatch up close and personal." The problem is that filmmakers need the hair to avoid an NC-17 rating. If the actress's nether regions are sufficiently concealed by hair, the MPAA will sometimes look the other way and give the film a less restrictive rating, depending on how exactly said region is shown in the movie. If the bare lady bits are shown, however, even briefly, getting a less restrictive rating is much less likely. Thus, erring on the side of caution, most directors will instruct the bare ladies to either grow out their hair down there for the nude scenes or put on a merkin. Australia is infamous for its abundance of absurdly dangerous wildlife, from highly venomous brown snakes and funnel web spiders to giant saltwater crocodiles and great white sharks. Nearly everything that slithers, crawls, or swims in the land down under seems perfectly designed to inflict the most horrible death possible. But one Aussie creature stands above the rest. Its sting so painful its victims literally beg for death. It's a creature so mysterious and so elusive that up to 60 years ago, science didn't even know it existed. For thousands of years, the Aborigines of Australia's northern coasts have known that to swim in the ocean between the months of November and May is to risk an ordeal beyond description. At first, the victim feels only a mild burning sensation, no more painful than a bee sting, but 10 to 15 minutes later, they're suddenly struck down with a crippling combination of symptoms. As Australian biologist Lisa Gershwin explains, it gives you incredible lower back pain that you would think of as similar to an electric drill drilling into your back. It gives you relentless nausea and vomiting. How does vomiting every minute to 2 minutes for up to 12 hours sound? Incredible. It gives waves of full body cramps, profuse sweating. The nurses have to wring out the bed sheets every 15 minutes. It gives you very great difficulty in breathing, where you just feel like you can't catch your breath. It gives you this weird muscular restlessness, so you can't stop moving, but every time you move it hurts. And if that wasn't enough, patients were also struck with an overwhelming feeling of looming dread. Patients believe they're going to die, and they're so certain of it that they'll actually beg the doctors to kill them just to get it over with. If the victim is lucky, these symptoms persist for up to 24 hours before gradually fading away. If not, severe hypertension can lead to death from heart failure or cerebral hemorrhage. As more and more white Australians began living and vacationing in the area around the Great Barrier Reef, reports of this mysterious syndrome began trickling back to the medical community. Among the first to study the phenomenon was Dr. Ronald Southcott, who in the 1940s dubbed the incidents type A stingings to distinguish them from the more well-known type B stingings inflicted by the Chironex fleckeri, the Australian box jellyfish. The box jellyfish is the bane of every Australian swimmer. Growing up to 30 centimeters wide with 60 tentacles 4 meters long, their nematocysts are among the fastest objects in the known world and are powerful enough to penetrate the carapace of a crab. The venom they deliver is so potent that a mere 2 meters of tentacle can kill a grown man in under 2 minutes. And if that wasn't enough, unlike regular jellyfish, which are largely blind and drift passively with ocean currents, box jellyfish possess 24 surprisingly sophisticated eyes and can swim at speeds of up to 3 knots. These creatures have killed around 100 Australians since record-keeping began and seriously injured countless more, and fear of them regularly shuts down beaches for 6 months of the year across a 5,000-kilometer stretch of Australia's northern coast. But despite its ubiquity, the venom of the box jellyfish did not match the highly specific symptoms of type A stingings, nor did any of the other usual suspects like the Portuguese man-o'-war. Southcott's research was taken up in the 1950s by Dr. Hugo Flecker, a pioneer of jellyfish research and the namesake of Chironex fleckeri. While Flecker suspected that type A stingings were caused by some sort of jellyfish, he was unable to find any nematocysts, the syringe-like stinging cells jellyfish use to inject their venom on any victims. Unable to finger a definitive culprit, in 1952, Flecker grouped these symptoms together under the name Irukandji syndrome. This was named after an Aboriginal tribe native to the area of northern Australia where the phenomenon was most common. For nearly a decade, the cause of Irukandji syndrome remained a mystery until, in 1958, an eccentric doctor named Jack Barnes arrived in the northern town of Cairns. Born on April 2, 1922, on a sheep station outside Charleville, Queensland in 1942, Jack Honeyside Barnes suspended his medical studies to enlist in the Australian Imperial Force and spend the war fighting the Japanese on the island of Timor. After the war, he returned to medicine, becoming medical superintendent of Thursday Island Hospital before setting up his own practice in Cairns in 1958. That year, he was tasked by the local branch of the British Medical Association with finally tracking down the cause of Irukandji syndrome. According to his associate, Dr. Graham Cossins, Barnes was irritable and belligerent, demanding and critical, unsociable and rude, but under that gruff exterior was a kindly and compassionate associate. This prickly personality also belied the sharp and analytical mind of a detective, which allowed Barnes to make several key deductions about his prey. First, as nobody had ever seen the creature, Barnes reasoned it must be very small and nearly transparent. Second, as most victims were stung in relatively shallow water, it must stay close to the surface. Third, as stingings tended to occur in clusters, it must occur in large numbers. And finally, the creature must be mobile, as none had ever been found washed up on the beach. Poring through hospital reports, Barnes discovered that 85% of irukandji cases occurred in only two places, Palm and Ellis beaches, and after analysing tidal charts, he quickly discovered why. Every winter, sustained northerly winds reversed local tidal flows, bringing in fresh currents from the Timor and Coral Seas, and with them the causative agent of irukandji syndrome. It was here that Barnes focused his search for the elusive irukandji creature. Over the next 3 years, Barnes spent hundreds of hours sitting on the seafloor in a weighted diving suit, laying out traps cobbled together from flour sifters and staring upward in the hopes of spotting the creature silhouetted against the sunlight filtering down from the surface. It was tedious, unrewarding work, with Barnes's traps quickly becoming clogged with assorted marine life. But on December 10, 1961, his patience paid off as he finally found what he was looking for, a tiny, nearly transparent jellyfish barely more than a centimetre across. On the same day, another specimen was caught by lifeguard Don Ludbay, who noticed a small, nearly invisible creature clinging by one tentacle to an erratically swimming fish. But was this tiny creature really the cause of irukandji syndrome? While most scientists would have started by analysing the venom's chemical composition or testing the creature's sting on an animal, Barnes had other ideas, skipping straight to human experimentation. As for the test subjects, this included Barnes himself, of course, along with local lifeguard Chilla Ross, and controversially, Barnes's own 9-year-old son Nick. Barnes's description of what happened next from his 1964 paper Cause and Effect in Irukandji Stinging is disturbingly clinical and detached, perhaps appropriately for a father who no doubt sentenced his son to a lifetime of crippling trust issues. The first carabinea was applied to an adult, JB, and to a boy aged 9 years, NB. A robust young lifesaver, CR, volunteered to test the second specimen, of similar size to the first. The jellyfish was placed in contact with the inner surface of the upper arm of each volunteer. The effects were not long in coming. The lad reported mild abdominal pain 12 minutes after being stung, and 2 minutes later declared he had an ache in both armpits, that abdominal pain was worsening rapidly, and that his back was hurting. Within 20 minutes, the two adults noticed aching in both axillae, followed almost immediately by backache and by discomfort around the lower ribs interiorly. Back pain was maximal in the sacral area, deep and boring in nature. Severe abdominal pain, the most constant feature of the irukandji syndrome, was well established in all cases within 30 minutes. Subjects were seized with a remarkable restlessness and were in constant movement. As the pains increased, initiative was notably depressed, and cerebration, though accurate, was decidedly sluggish. Palpation of painful areas, now including arms and legs, showed muscle groups in tonic contraction, little short of spasm. This possibly explains the peculiar postures noted, for extremes of flexion and extension were avoided, and the volunteers adopted a stance which I can best liken to that of an infant with a full nappy. During the 20-minute drive to Cairns, the victims were in considerable distress, heightened, it seemed, by the necessity to remain seated. All had abdominal and back pain, pain in the anterior chest wall with some difficulty in breathing, and diffuse aches in muscles and joints. NB felt very cold and was shivering violently. 40 minutes after the stinging, the abdominal musculature of the three subjects was in unrelenting spasm, so rigid as to warrant fully the term board-like. Undoubtedly, the advent of coughing and retching marked the peak of misery for the two adults. Each spasm increased the gripping pains in the chest and abdomen, and as these eased, the cycle was repeated. This absurdly reckless experiment confirmed Barnes's suspicion that this tiny, seemingly innocuous jellyfish was indeed the cause of the mysterious irukandji syndrome. Following the publication of Barnes's groundbreaking paper in 1964, the creature was dubbed Carukia barnesi in his honor. Over the next decade, Barnes dedicated his life to the study of the irukandji and other jellyfish, mobilizing a network of medical practitioners to report cases of irukandji stingings and inform bathers of the danger. In the course of his research, he discovered that many jellyfish refused to sting through a synthetic barrier and took to wearing women's pantyhose while wading in the ocean to collect samples. This practice was soon widely adopted among lifeguards. Barnes also pioneered the now common practice of washing a jellyfish sting with alcohol or vinegar to kill any remaining stinging cells. Barnes was appointed a member of the British Empire in 1970 for his work, and he died in 1985 of a heart attack. Though he ultimately succeeded in passing on his mad scientist genes, his reckless approach to toxicology won him the title of At-Risk Survivor at the 1997 Darwin Awards. Bonus facts. In case snakes, spiders, jellyfish, crocodiles, and sharks aren't enough to discourage you from visiting Australia, here are a few more lesser-known dangerous animals native to the land down under. While the irukandji and box jellyfish are infamous for their painful stings, if you really want to know what pain is, then simply find the nearest stonefish and step on it. Comprising 5 species native to the Pacific and Indian Oceans, stonefish are so named for their remarkable resemblance to an algae-covered rock, which allows them to lay perfectly camouflaged among the coral waiting for prey to swim by. If threatened or stepped on, the stonefish raises a set of razor-sharp dorsal fin spikes which can easily pierce a sandal or diving boot and inject the most powerful venom of any known fish. The effect of this venom is often described as the worst pain in the world, so much so that death by stonefish is typically not due to the venom itself, but rather the shock induced by the sheer agony. Thankfully, however, an antivenom is available, and treating the wound with very hot water effectively breaks down and neutralizes the venom, meaning that fatalities are relatively rare. Back on the surface, perhaps the most well-known Australian bird is the emu, a giant flightless rat-eyed famous for defeating an army of machine gun-wielding soldiers in what has come to be known as the Emu War of 1932. But as badass as that feat is, the emu has nothing on the cassowary. Standing at 2 meters tall and capable of running at speeds of up to 50 kilometers an hour, the cassowary is armed with a fearsome 12-centimeter claw on its center toe, capable of inflicting a deadly kick when threatened. Its skull is also equipped with a thick bony ridge or casque that allows the bird to run full tilt through dense vegetation. Despite its intimidating appearance, however, the cassowary is a shy and solitary bird living mainly on fruits and berries in the dense rainforests of northwestern Australia. However, in recent years, urban and agricultural development has led to the significant loss of the cassowary's preferred habitat, increasingly forcing the birds to wander into urban areas looking for food and increasing the chances of a deadly encounter with humans. But if you thought for a moment that you would find safety in the realm of flying birds, then think again. In 2017, an article in the Journal of Ethnobiology by Robert Gosford, Mark Bonter, and others presented the first recorded evidence of a phenomenon that had been reported by Australian Aborigines for thousands of years. The team observed birds of prey such as the black kite, whistling kite, and brown falcon lifting burning branches from brush fires and using them to start fires elsewhere. The birds would then pick off mice and other small animals fleeing the blaze or feast on the charred corpses of the ones who didn't make it. Because, of course, corpse-eating arsonist birds are a thing in Australia. And finally, we come to the most distinctively weird of all Aussie animals, the duck-billed platypus. While this egg-laying, half-duck, half-beaver-looking creature may look adorable and harmless, the male of the species packs a powerful punch in the form of 2 sharp spurs on its hind legs. These are capable of delivering a peptide-based venom whose effects have been described as excruciating and resistant to the most common painkillers such as morphine. The extensive swelling induced by the venom can last for months, while residual pain can persist for years. Interestingly, the fossil record suggests that until relatively recently, venomous spurs were a common feature of many mammals, with the platypus being the sole surviving possessor of this trait, and of course we'd only expect to find it in Australia. Mithridates VI, also known as Mithridates the Great, was the ruler of the Kingdom of Pontus, a region of northern Anatolia in what is now modern-day Turkey, from 120 to 63 BC. In 120 BC, Mithridates' father, Mithridates V, was assassinated by poison, allegedly as part of a conspiracy led by his wife, Queen Laodice VI. Throughout his life, the younger Mithridates lived in fear of being poisoned, and began taking small, non-lethal doses of various poisons in order to build up an immunity. After a series of wars against the Roman Empire, in 66 BC, Mithridates was defeated by Roman general Pompey at the Battle of Lysus and forced to retreat to the city of Pantikapaeum on the Black Sea. There he hoped to gather another army to fight the Romans, but the local population rebelled against his rule and he was forced to commit suicide. At first, Mithridates attempted to drink poison, but as he had already built up an immunity, this had no effect, and he instead had to ask his bodyguard, Bituitus, to run him through with his sword. Ever since, this practice known as Mithridatism has appeared in countless works of fiction, perhaps most memorably in the 1987 film The Princess Bride. But is it really possible to immunize yourself against poison by taking tiny doses over time, just like the Dread Pirate Roberts? Well, yes and no. The body's ability to tolerate a given poison depends on its ability to metabolize or break down said poison into a less toxic form, a task largely accomplished by enzymes in the liver. Thus, the poisons one can build immunity to tend to be larger organic molecules. One common example of this is ordinary grain alcohol, or ethanol, which is toxic if consumed in large quantities. The body actually has 2 lines of defense against ethanol, the stomach and the liver. The stomach secretes small quantities of an enzyme called alcohol dehydrogenase, which converts ethanol into less toxic acetaldehyde. This mechanism exists to counter the small amounts of ethanol, around 3 grams per day, generated naturally by the fermentation of food in the stomach. However, this small amount of dehydrogenase is easily overwhelmed by most alcoholic beverages, so most of the alcohol we consume is metabolized in the liver. Here, as in the stomach, ethanol is converted into acetaldehyde by alcohol dehydrogenase. However, as acetaldehyde is also toxic, it must then be acted upon by another enzyme called acetaldehyde dehydrogenase, which converts it into harmless acetic acid, the main ingredient in white vinegar. Acetic acid is further broken down into carbon dioxide and water, which can then be expelled by the lungs and kidneys. When a person drinks heavily and often, it can stimulate the liver to produce larger quantities of alcohol and acetaldehyde dehydrogenase, accelerating the metabolic process and gradually building up a tolerance to alcohol. However, this process can only go so far. An excess of alcohol dehydrogenase can lead to a buildup of toxic acetaldehyde, which can cause alcoholic fatty liver disease, a common affliction among those with chronic alcoholism. This is particularly dangerous for certain individuals, including around 50% of those of Northern Asian descent who, thanks to a mutated gene, produce a less efficient version of the acetaldehyde hydrogenase enzyme. This leads to the rapid onset of acetaldehyde poisoning symptoms, including skin flushing, sweating, increased heart rate, and nausea, even after mild alcoholic consumption. Increased levels of alcohol dehydrogenase can also accelerate the metabolism of other substances, such as the barbiturates in sleeping pills, leading the user to take larger amounts and risk overdosing. The rapid breakdown of acetaminophen, a common painkiller, also produces a number of substances toxic to the liver, making this drug potentially dangerous to those with chronic alcoholism. These defense mechanisms can also backfire in other ways, such as when a person consumes methanol. Methanol, or wood alcohol, smells and tastes nearly identical to ethanol, but when ingested, it can be deadly. This is because when acted upon by alcohol dehydrogenase, methanol breaks down into formaldehyde, the chemical used to embalm corpses and preserve biological specimens. Acetaldehyde dehydrogenase further breaks down formaldehyde into formic acid, a highly toxic substance that immediately attacks the optic nerve, causing one of the first symptoms of methanol poisoning, permanent blindness. Formic acid and formaldehyde are also cellular poisons, and in high quantities cause the victim's body to slip into a coma and shut down. During Prohibition in the 1920s, the United States government added methanol to industrial alcohol, a process known as denaturing, in order to prevent it from being diverted for human consumption. But vast quantities of this denatured alcohol still made it onto the black market, leading to the deaths of an estimated 10,000 people. Another type of poison to which humans can become at least partially immune is the venom of snakes. While composition varies from species to species, snake venom generally contains a combination of complex enzymes such as proteases to dissolve tissues, nucleases to break down DNA, cholinesterase inhibitors to impede nerve function, ATPases to rob cells of their energy, and anticoagulants to encourage bleeding, all of which ensures that whatever creature the snake bites is guaranteed to have a very bad day. Yet despite snakes possessing this seemingly overpowered cocktail of death, many animals are effectively immune to their bite, including the mongoose, secretary bird, garden dormouse, hedgehog, wood rat, opossum, California ground squirrel, and yes, everyone's favorite furry badass, the honey badger. The biological mechanisms which confer this immunity vary widely. Opossum blood contains a peptide that breaks down snake venom proteins, while the proteins of mongoose cell membranes feature a mutation that protects them from venom proteases. While humans have no such natural protection, it is possible for us to build up a tolerance to snake venom. In fact, inoculation against snakes and other venomous animals is one of the oldest forms of vaccination, with cultures throughout history, such as the Pakoku snake cult of Myanmar, injecting or tattooing their skin with small doses of venom in order to gain immunity. Unlike with alcohol tolerance, protection is conferred not via metabolic enzymes, but rather the immune system, with each exposure generating antibodies to that specific venom. If the inoculated person is bitten again, these antibodies will recognize and latch onto the venom proteins, allowing the immune cells to neutralize them. In more recent years, researchers such as Charles Tanner, Herschel Flowers, and Joel LaRocque have confirmed the effectiveness of this practice by injecting themselves with pure or dried venom. This research has led to the development of the first effective antivenoms, which are traditionally manufactured by injecting horses with venom, collecting their blood, and purifying the resulting antibodies. However, there have been numerous incidents where the immune system of snakebite victims have rejected the horse proteins, leading a number of scientists to continue self-experimentation in order to make a safer antivenom. Among the most extreme of these is Tim Fried, a self-taught immunologist biologist from Wisconsin who, over the last 17 years, has endured over 200 bites from some of the world's deadliest snakes. And the results speak for themselves. A bite from an African black mamba usually results in an agonizing death within 15 minutes. But for Freed, its effects are, according to him, no worse than a couple of bee stings. Working with Dr. Brian Hanley, a microbiologist at the University of California and founder of gene therapy startup Butterfly Sciences, Freed hopes that his blood will lead to the development of a universal antivenom for all Old World snakes. Another strange case is that of British rock musician Steve Ludwin, who has been injecting himself with snake venom for the past 40 years. Ludwin's first encounter with snake venom came at the age of just 10 when he visited legendary reptile handler Bill Hast's Serpentarium in Florida. Bill Hast came out and draped an indigo snake around my neck. I was aware that he had been injecting himself with snake venom, and I just thought it was the wildest thing I'd ever heard. When I was 17, I knew I was going to inject snake venom in the future. I felt like Richard Dreyfuss in Close Encounters of the Third Kind when he had that feeling, this means something. But you know, I've always loved snakes. I had no idea what it would do to me, but I knew it had been done before and was curious to see if it was possible to become immune to snake venom. Ludwin began injecting snake venom in October of 1988, slowly working his way up through larger doses and more venomous species. One day in 1991, he injected himself with a mixture drawn from the Pacific rattlesnake, eyelash viper, and green tree viper, only to realize that he had gone too far. My arm was all red and doughy with a sack of liquid hanging from it, and I could see the blood vessels appear. It was like something out of Evil Dead. Ludwin finally decided to go to the hospital where the emergency room doctors who had never treated a snake bite before administered the common rattlesnake antivenom Crofab. But after spending 3 days in intensive care without improvement, Ludwin decided to discharge himself from hospital. Incredibly, despite the doctor's warnings that he would either die or lose his hand, within a week his arm had returned to normal. A recovery Ludwin attributes to his immunization regimen. Today, Ludwin frequently travels to Denmark to have his blood drawn by researchers from the University of Copenhagen and the biotech startup Venom AB. Like Tim Freed, Ludwin hopes that his unique antibodies will eventually lead to a universal antidote for snake bites, which, according to the World Health Organization, kill 125,000 people every single year. When it comes to simpler inorganic poisons, however, the prospective Mithridatus is unfortunately out of luck. The majority of these poisons either can't be broken down by the body or break down into even more toxic substances. Heavy metals like lead, antimony, or cadmium are cumulative poisons, meaning that rather than being metabolized or flushed out of the body, they slowly accumulate within tissues, their toxic effect only growing over time. Certain metals like plutonium, strontium, or radium can be mistaken by the body for calcium or phosphorus and used in its place in forming bones, making it extremely difficult to remove. In addition to being conventionally toxic, these metals are also radioactive and can lead to the development of bone cancer or leukemia. Another common accumulative metal is mercury, which tends to collect in the brain. Indeed, this is the origin of the term mad as a hatter, as milliners would often use various mercury compounds to soften the felt used in making hats, eventually developing chronic mercury poisoning and psychosis. One seeming exception to this rule is arsenic, to which people can actually develop a certain tolerance. In 2012, researchers from Lund and Uppsala universities in Sweden conducted a study on the residents of the small Argentinian town of San Antonio de los Cobras in the Andes, where, thanks to natural mineral deposits and centuries of copper mining, the groundwater contains extremely elevated levels of arsenic. They found that a large proportion of the town's population possesses a gene called AS3MT, which allows the body to expel arsenic more efficiently. However, this ability was gained not through individual exposure, but collectively through natural selection over the past 1,000 years. It is not possible for an individual to consume small quantities of arsenic and become immune. Another partial exception is cyanide, which the liver can metabolize in small quantities using the enzyme rhodinase. This converts it to the less toxic thiocyanate. This allows the body to tolerate the small amounts of cyanide found in foods such as apple seeds or almonds. However, unlike alcohol, it is not possible to stimulate the liver to more quickly metabolize cyanide. While the liver can produce more rhodinase, the reaction also depends on the compound thiosulfate, whose supply in the body is limited and cannot be increased. Yet throughout history, there have been individuals who appeared to be completely immune to cyanide poisoning. One such person was Grigory Rasputin, the Russian mystic who held great sway over the court of Tsar Nicholas II. In 1916, a group of noblemen, led by Prince Yusupov, plotted to assassinate Rasputin, inviting him to Yusupov's home in St. Petersburg, where they offered him wine and cakes laced with cyanide. While Rasputin initially refused, he eventually relented it and ate the food seemingly without ill effect. This forced Yusupov and his co-conspirators to shoot Rasputin, wrap him in a carpet, and dump him in the frozen Neva River. Rasputin's immunity to the poison is often attributed to his mystical powers, but the actual explanation is likely far more mundane. The poison the conspirators fed him was likely either potassium or sodium cyanide, which cannot be directly absorbed into the bloodstream. Instead, it must first react with the hydrochloric acid in the stomach, producing hydrogen cyanide gas, which can then be absorbed through the stomach wall. Due to a variety of factors, including genetics or various diseases, certain individuals cannot produce stomach acid, a condition known as hypochlorohydria. If Rasputin was such an individual, then the cyanide would simply have sat harmlessly in his stomach, making him appear to be immune. So unless your enemies plan to attack you with poisonous snakes, and if so, your life is probably awesome, unfortunately Mithridatism appears to be largely the stuff of fiction. If you've ever won a competition, chances are high that you want to do it again. So, if someone offers you an edge, temptation is high to use it, no matter the cost. May it be a drink from the gods or an injection by your coach. Over the centuries, there were lots of things that people used to enhance their performance. And enter the picture, steroids! But as with all drugs, these also come with some not so desired effects, which brings us to the topic of the hour. Why do steroids make your balls smaller, and does the same thing happen to a woman's ovaries? To understand the answer to those questions, we must first look at exactly what steroids are and how they affect the body. To begin with, steroids are a part of the huge family of lipids. We know them best for their function as storage for energy, but without lipids, not a one of us would be sitting here, as one of their main functions is as structural components in the cell membrane. But lipids are also used as molecules which transfer signals in the body. For the topic at hand, we are only going to look at one molecule, cholesterol. While many people have only heard of cholesterol for potential in clogging your arteries until you go belly up, among other things, it's also the starting substance if you want to make a certain class of hormones. Steroid hormones, to be exact. Hormones are nothing else but chemical messengers your body is using to control organ function and metabolism. Cholesterol can be metabolized into different steroid hormones. Depending on where in your body the reaction takes place, different types of steroid hormones are synthesized. In the cortex of the suprarenal glands, the ovaries, the placenta, or in the testicles. And yes, we'll get back to your balls soon, so sit tight. So, which hormones derive from cholesterol? There are the glucocorticoids. You might know its most important representative, the stress hormone cortisol. Then there are the mineralocorticoids, which regulate the salt and water balance in your body. Their primary representative is aldosterone. Then, and drumroll please, there are the male and female sex steroids. Primary function of the sex steroids or sex hormones is the development of sexual characteristics. They basically decide your sex in your mother's womb and then hit quite hard again during puberty. But what has all of this got to do with doping? Well, in a word, that's testosterone. Testosterone as the primary androgen or male sex hormone has two main effects: virilization and anabolism. It is responsible for maturing the male sex organs before birth and the appearance of the secondary sex characteristics during puberty, but one of its effects is also the growth of muscle mass and strength. That's also, of course, the reason why in sports there are often different sports leagues for men and women. Before a child hits puberty, there is no real significant sex difference in athletic performance, but as circulating testosterone rises in males, so does their physical advantages in strength, speed, and endurance. These account for at least an 8 to 12% ergogenic advantage in men. Okay, and this all brings us back to your balls. The observation that there is a connection between certain characteristics and behaviors and the testicles is very old. First, castration of cattle and sheep took place during the Neolithic period when humans first started farming. Fast forward to the end of the 19th century and the British physiologist and neurologist Charles Edward Brown-Séquard started to self-inject a secretion from the testicles of freshly killed guinea pigs. He argued that these auto-injections resulted in a rejuvenated body and an increase in strength. Although the amount of testosterone in these injections was probably too small to show any effect, he was essentially the first human trying to dope himself with anabolic steroids. The German physician and pharmacologist Ernst Lacher was already part of a group who first described the female sex hormone estrogen. Next, he successfully isolated testosterone from the testicles of a bull in 1935. From here, the misuse of testosterone in professional sports started around the mid-20th century by Russian weightlifters. During the 1954 World Weightlifting Championships in Vienna, Austria, John Ziegler, a doctor accompanying the US team, managed to get the secret out of the USSR's team doctor over some vodkas, of course. Back in the US, he started to experiment with testosterone, first trying it out on himself, then on some athletes. Accounts of the early successes vary. Some say testosterone had no effect. Others say that they gained a lot more strength than was expected from their training regimen. The doc kept on experimenting and started to develop a synthetic substance that was similar to testosterone but without its negative side effects, or at least lessened the side effects. The drug was marketed in 1958 under the name Dianabol and was intended to be used on severely debilitated patients like burn victims, where it could be used to help build up muscles with only a minimum of activity. But Doc Ziegler also started some of his weightlifters on the new drug. As the results on patients were great, his intention was to see what the drug could do to healthy, well-conditioned athletes. The doses regimen he used was very low compared to what athletes used later on, but still, the results were outstanding. From there, the abuse of anabolic steroids spread first in professional sports, but from the 1980s also into the general population, either to improve athletic performance or simply often used by young men to improve personal appearance. In fact, according to the United States National Institute on Drug Abuse, the biggest group misusing steroids are male non-athlete weightlifters in their 20s or 30s. But why is it so bad to use these drugs? Well, to begin with, people who misuse steroids often use dosages that are 10 to 100 times higher than the doses which are usually prescribed for medical conditions. As side effects are usually dosage dependent, that makes things even worse. Long-term effects include kidney problems up to kidney failure, liver damage and tumors, enlarged heart, high blood pressure, and changes in blood cholesterol, all of which increase the risk of stroke and heart attack, even in young people. And if this wasn't bad enough, there's also an increased risk of blood clots. In men, sperm count also decreases, they go bald, develop breasts, have an increased risk of prostate cancer, and of course, then there are the balls. So, let's take a look at your balls, shall we? Why do they shrink when using steroids? Hormones in our bodies are very tightly controlled. For testosterone, that means that first, very specific things must happen in your brain for them to be released. The hypothalamus is one of the most important regulatory centers for certain metabolic processes. It all starts with gonadotropin-releasing hormone, GnRH, being secreted there. GnRH then stimulates the release of follicle stimulation hormone, FSH, from another part of your brain, the pituitary gland. FSH affects the testicles, so they secrete testosterone. Once testosterone is released, it reports back to your brain, and your brain knows to tone down the production of GnRH and FSH. That means if there is enough testosterone circulating in your body, your brain stops telling your balls to produce it. So it's basically use it or lose it. If there is always enough testosterone in your body because you put it in your body artificially by some means, your testicles, not needing to do this, start shrinking. But what about women? Does testosterone even have an effect on them? And if they use it, do their ovaries shrink as well? First things first, yes, testosterone has the same effects on women as it does have on men. It's just that the ladies' testosterone level is much, much lower than it is in men, usually around 15 times lower to be precise. Also, if you thought that sex hormones are only produced in your sex organs, well, wrong again. Testosterone and estrogen are both synthesized in the adrenal glands to a lesser degree, of course, and estrogen is also produced by fat tissue. Even if a woman takes testosterone, her ovaries still have a job to do, so they don't start shrinking. But think back to what are the two functions of testosterone: anabolism and virilization. So the woman will gain muscle mass, but her body will also become more male-like in certain other aspects. Common side effects in women taking steroids include growth of facial hair or excess body hair, decreased breast size, male pattern baldness, changes in or even stopping the menstrual cycle, enlarged clitoris, and deepened voice. Some of these effects are permanent, so they persist even when the woman stops taking testosterone. Incidentally, one more side effect of testosterone we haven't talked about affects specifically young people taking testosterone. If you are a teen and taking testosterone before your growth spurt, you will end up with stunted height, or even if you only start taking it after the growth spurt, your height will still be lessened. As to why, when the sex hormones hit a certain level, it also signals the body that it is time to stop growing. If you raise that that hormone level artificially earlier than your body would have done, your body also reads this signal in this and just stops growing. Unfortunately, this is also a permanent effect because stopping to grow means that a part of your bones, which was cartilage until that point, reforms into bone material. But this cartilage is necessary for a bone to keep growing. Once the ossification, making cartilage into bone, is done, there is no way back, and even if the use of testosterone is stopped, there will still be no more growth spurts. And now for some bonus facts. Women suffering from polycystic ovary syndrome are overrepresented in elite sports. Even though you might have never heard of this condition, it is the most common endocrine disorder among women aged 18 to 44 and the most common cause of infertility due to lack of ovulation. Polycystic ovary syndrome leads to mild hyperandrogenism. There is a hormonal imbalance with a little more testosterone in women with this condition than in the general female population. Even though their testosterone levels are still much lower than the testosterone levels in men, this mild increase in some cases is enough to give these women an edge over other women in sports competitions, thus leading to them being overrepresented in athletics. The clitoris and the head of the penis start out from the same tissue during embryogenesis. If you're very observant, you can see or feel that when a woman is sexually aroused, the clitoris, as well as the small labia, are also swelling similar to the erectile tissue in the penis. Unsurprisingly, from this, the tissues have a similar origin. Testosterone has an effect on the clitoris, and in the presence of higher than usual levels of testosterone in a woman, the clitoris becomes enlarged, sometimes extremely so, strongly resembling a small penis in some extreme cases.
We've all seen it in movies. A character will be going along in their lives blissfully unaware of some extremely traumatic event in their long-distant past. That is, until a bit of syrup dribbles onto their cheek and they are transported back in their mind to that time they were abducted by aliens. Suddenly they remember everything. But, well, do such repressed memories actually exist? It turns out that while only a few decades ago the idea of repressed memories was an extremely popular notion among psychologists, including many a person being thrown into prison when someone would randomly recover such a traumatic memory from their childhood after undergoing psychotherapy to retrieve it, the issue is a bit more controversial today. According to a study conducted at the University of California, Irvine, published in the Journal of the Association of Psychological Science in 2013, approximately 60 to 90% of psychologists, varying based on therapist type, who are clinicians, still believe that repressed memories exist in some cases, though generally they are considered to be rare. Further, 43 to 75% think these repressed memories can be retrieved with proper methods. In stark contrast, approximately 70% of research psychologists believe there is no such thing as repressed memories. So, well, what's going on here? To begin with, on the research psychologist side, their stance is largely backed by the fact that, as noted by famed psychologist Chris French of the University of London, there is no convincing evidence to support the existence of the psychoanalytic concept of repression, despite it being a widely accepted concept. Despite this, many clinicians still believe it is. As to why, Lawrence Patterhis of the aforementioned study illustrating the divide between clinicians and researchers speculates clinicians are more apt to trust clinical experience, while researchers tend to trust experimental research. There are many anecdotal reports of cures coming from retrieving repressed memories, but at the same time, credible experimental evidence of it does not exist. Further stacking the evidence on the side of the researchers, it turns out that traumatic events that induce a strong emotional response, which are so often the subject of supposed repressed memories, tend to be the ones we remember the best. That said, traumatic events can and often are ultimately forgotten, particularly when said events don't actually induce a significant emotional response. For instance, a child might experience something that would normally be called traumatic but doesn't realize it's a traumatic event, so doesn't associate a strong emotional response with it. These tend to be forgotten at much higher rates, similar to what you'd expect from any given memory. In fact, in one study, Recall of Childhood Trauma, a prospective study of women's memories of child sexual abuse published in the Journal of Consulting and Clinical Psychology, it's noted that 38% of the adults studied who had a high probability of being abused as children based on documented evidence had forgotten about it as adults. In one case, one of the participants, who was adamant she had never been sexually abused, was asked a follow-up question if she knew anyone that had been in trouble for his or her sexual behavior. Eventually, the woman did remember that her uncle had. She stated, "I never met my uncle. He died before I was born. You see, he molested a little boy. When the little boy's mother found out the son was molested, she took a butcher knife and stabbed my uncle in the heart, killing him." In fact, that is exactly what had happened, except in this case the woman being interviewed was one of the children the uncle had allegedly done this to, resulting in the mother of one of the children murdering him with a knife. The now adult woman in the study had only been 4 years old at the time, a time when few remember anything of their lives, traumatic or not. Similarly, in a case reported by the Recovered Memory Project, a woman named Claudia was involved in a group therapy session to help with weight loss when, for whatever reason, she began remembering being sexually abused by her older brother when she was little. Her brother had died in Vietnam approximately 15 years before, and their parents had essentially left his room and belongings alone. When she returned home, Claudia searched the room and found not only a set of handcuffs in his closet, but a diary in which he supposedly recorded his, to quote, sexual experiments with his sister. From many such cases as these, as should come as no surprise to anyone, humans tend to forget things all the time, and later, sometimes they remember them. It's just that studies to date don't really demonstrate that the brain is actively repressing these memories, as is so widely believed among the general public and, to a lesser extent, clinical psychologists. While this might otherwise be a mundane issue only worth psychologists arguing over, it turns out it's actually a pretty pernicious one thanks to the way clinicians classically tried to recover these memories, particularly in the 1980s and 1990s when the idea of recovering repressed memories was en vogue. This was often done in cases where forgotten traumatic events were thought by therapists as the causes of things like depression and anxiety in a given client. It turns out many of the methods used by psychologists came to be discovered as textbook ways to get people to create false memories. To begin with, to illustrate how easy it is to plant a false memory, in one early study, now famed memory researcher Dr. Elizabeth Loftus and co. decided to see if they could implant a false memory into people of having been lost at a shopping mall when they were 5 years old. Their method here, as explained by Dr. Loftus, was: we prepared a booklet for each participant containing one-paragraph stories about 3 events that had actually happened to him or her and 1 that had not. We constructed the false event using information about a plausible shopping trip provided by a relative, who also verified that the participant had not, in fact, been lost at about the age of 5. The lost in the mall scenario included the following elements: lost for an extended period, crying, aid and comfort by an elderly woman, and finally, reunion with the family. What they ultimately found was, after asking people to recall the events with as much detail as possible, a question many a clinical psychologist would ask among other methods, almost 1/3 of the people involved remembered this experience. In yet another similar study at Western Washington University, parents of students reported various events that had happened to their children. The researchers then asked the students if they could give their version of the story to illustrate how people remember things differently. They also planted a false story within these real ones about either being hospitalized as a child or having had a birthday party with a clown and pizza at the age of 5. It was also confirmed with the parents that neither of those things ever happened. Illustrating the power of suggestion, not a single student remembered the false event the first time they were interviewed about it. Yet, in a second interview, 1/5 of them remembered it after thinking about it for a while. Some even eventually remembered the event in incredible detail, including specific people visiting them in the hospital. In yet another study by the same research group, this time they went with the subjects having to evacuate a store as a child when the sprinkler system went off, drenching everyone, or having spilled a giant bowl of punch at a wedding directly on the parents of the bride. Once again, nobody remembered the false memory the first time, but the second time, almost 1/5 did, including, again, with some remembering remarkably vivid and small details. Going yet more traumatic and somewhat controversial, there have been studies where researchers implanted false memories of everything from people almost drowning as children to being demon-possessed, all with similar results. Of course, in many of these cases, the idea was fed to the subjects, and some of them then created the detailed false memories based on that suggestion. So, how do these correlate to methods used by clinical psychologists in the late 20th century and, to a lesser extent, now? As one example, we have imagination therapy, where patients are asked to imagine an often traumatic event and not worry about whether it happened or not, a once very popular method for trying to draw out repressed or forgotten memories. For example, as famed sex therapist Wendy Mattles once stated, she would tell her patients to spend time imagining you were sexually abused without worrying about accuracy, proving anything, or having your ideas make sense. Ask yourself these questions. What time of day is it? Where are you? Indoors or outdoors? What kind of things are happening? Is there one or more person with you? Who would have been likely perpetrators? When were you most vulnerable to sexual abuse in your life? In studies looking at whether this type of imagination therapy increases the likelihood of implanting a false memory, one study's subjects were asked a series of questions about a made-up event of running toward a window as a child, then tripping and breaking the window with their hands as they fell.
It turns out that the act of imagining that it happened increased about 1 in 4 of the participants' confidence that the event had actually happened, versus only about 1 in 10 reporting an increase in confidence when not asked to imagine the event had occurred. Other studies have shown that the more frequently subjects were made to imagine a made-up event, the more and more likely they are to later state that the event actually happened. In yet another study, using these type of guided methods as well as hypnosis, participants were made to supposedly recover memories from directly after they were first born. Of course, the researchers at Carleton University actually simply implanted specific memories. Incredibly, 95% of people being studied using guided mnemonic restructuring came to remember some memories from directly after birth. And on the other hand, 70% who were subjected to hypnosis also recovered these so-called impossible memories. Also important to note is that about half of the groups also remembered the specific memory from shortly after being born that the researchers had completely made up. Dr. Loftus states of all of this, "Research is beginning to give us an understanding of how false memories of complete emotional and self-participatory experiences are created in adults. First, there are social demands on individuals to remember. For instance, researchers exert some pressure on participants in a study to come up with memories. Second, memory construction by imagining events can be explicitly encouraged when people are having trouble remembering. And finally, individuals can be encouraged not to think about whether their constructions are real or not. Creation of false memories is most likely to occur when these external factors are present, whether in an experimental setting, in a therapeutic setting, or during everyday activities." This, very unfortunately, resulted in cases like Nadine Kuhl. In 1986, she went to see a psychiatrist who in turn used a variety of popular techniques, including hypnosis, to try to see if she had any repressed memories about being abused as a child. In the end, what surfaced were memories of being raped, being forced into bestiality, eating babies, watching her friend get murdered, being forced to be involved in a satanic cult, etc. At one point, the psychiatrist in question even decided she had at least 120 distinct personalities, one of which was somehow that of a duck. And then, apparently, because this wasn't bizarre enough, she had an exorcism performed on her body to get Satan out. Of course, after years of this, it ultimately became clear none of these things had actually happened to her, and they were simply false memories inadvertently implanted by her psychiatrist over time using these various methods. In another famous case, one Beth Rutherford's therapists used similar methods to try and recover repressed memories in 1992, only to have her vividly remember her mother holding her down while her father, a minister, raped her countless times over the course of 7 years, starting when she was only 7 years old. This included twice getting her pregnant and then painfully aborting the pregnancies using a coat hanger. Naturally, the whole thing ruined her father's career and reputation, among other devastating effects on all involved. But it turns out none of that actually happened, which Beth ultimately discovered, among other evidence, when she went in for an examination, and it turned out that not only was it very clear she'd never been pregnant, but it was also of the opinion of her doctors that she was clearly still a virgin. Naturally, in both the cases of Beth and Nadine, neither were too pleased at having been put through all of that mental trauma, plus having put others they loved through similar stress and hardship when it was eventually demonstrated that none of the recovered memories had ever happened. Perhaps the most famous case of all of these was of Eileen Franklin, who would later go on to author a book called Sins of the Father, documenting the saga as she saw it. In her case, when she was a child, one of her friends, 8-year-old Susan Nason, was raped and murdered. Nason's body was discovered 2 months later, but the killer was never identified. That is, until Eileen was an adult, and her own daughter allegedly turned to look at her one day and reminded her so much of her friends that suddenly she remembered witnessing her own father, George Franklin, raping and murdering Nason right in front of her. Soon enough, Franklin was arrested, tried, and convicted, despite there not being any real evidence other than this recovered memory. Finally, 6 years after being imprisoned, the ruling was overturned by a federal appeals court who, among other things, noted that the prosecutor's entire case depended on the accuracy of repressed memories which were unreliable. In this case, they were taken as absolute fact, despite the lack of corroborating evidence. The appeals court also criticized the judge involved for not allowing the defense to introduce evidence that all of the pertinent facts of the case Eileen supposedly remembered had actually appeared in news accounts of the crime which Eileen was privy to. This was particularly important as much of the confidence that Eileen's memories were real came from the fact that many of the details she recalled did indeed match up with the evidence of the case. Not long after, Franklin was released after 6 years in prison. Prosecutors were initially going to forge ahead and attempt to get Franklin thrown back behind bars, but then a few pertinent pieces of information came out that resulted in them moving to dismiss the charges. First, Eileen had alleged that she had recovered another memory of her father raping and murdering someone else, this time an 18-year-old woman whose murder at that point was also unsolved. However, when a DNA test was done on the semen recovered, it didn't match George Franklin's DNA. Further, minutes from a meeting at his work at the time of this particular murder showed that Franklin had indeed been at the fire station where he worked at that time. Thus, unless he had discovered a way to be in two places at once, well, he couldn't have done it. The nail in the coffin on the original case was when Eileen's sister Janice told the prosecutors that Eileen allegedly told her that she had remembered the events of the case in question while being hypnotized, contrary to what Eileen and Janice had stated during the trial. If true, this made those memories unreliable in the eyes of the court thanks to a Supreme Court ruling on a similar case, and thus the prosecution finally decided to have the charges dismissed. Eileen, however, at this point firmly maintained she remembered these things happening and was still convinced her father was guilty of this and other alleged crimes from later recovered memories that she had of him raping her as well. But as the aforementioned psychologist Dr. Elizabeth Loftus, who was called to testify in this particular case, noted during the whole ordeal, I have little doubt that Eileen Franklin believes with every cell of her being that her father murdered Susan Nason. But I believe there is a very real possibility that the whole concoction was spun not from solid facts, but from vaporous breezes of wishes, dreams, fears, desires. Eileen's mind, operating independently of reality, went about its business of collecting ambiguities and inconsistencies and wrapping them up into a sensible package, revealing to her in one blinding moment of insight a coherent picture of the past that was nevertheless completely and utterly false. Eileen's story is her truth, but I believe it is a truth that never happened. Illustrating the potential scope of the problem of false memories in court cases, Dr. Loftus would later state in a TED Talk, in one project in the United States, information has been gathered on 300 innocent people, 300 defendants who were convicted of crimes they didn't do. They spent 10, 20, 30 years in prison for these crimes, and now DNA testing has proven that they are actually innocent. And when those cases have been analyzed, 3/4 of them are due to faulty eyewitness memory. Of course, moving back to recovered memories, there really are people who were abused or witnessed or endured traumatic things as children and then later completely forgot about it. So few are willing to reject the memories of everyone who has such recollections later in life, even when recovered through therapy. It's just that, as Dr. Loftus states, the one take-home message is this: just because someone tells you something with a lot of detail and emotion, it doesn't mean it actually happened. You need independent corroboration to know whether you're dealing with an authentic memory or something that is a product of some other process. She goes on, many people believe that memory works like a recording device. You just record the information, then you call it up and play it back when you want to answer questions or identify images. But decades of work in psychology has shown that this just isn't true. Our memories are constructive. They're reconstructive. Memory works a little bit more like a Wikipedia page. You can go in there and change it. But so can other people. So to sum up, while some psychologists still think repressed memories are a thing, there really isn't presently much data backing up the notion versus the simpler explanation that people have just simply forgotten things, like they forget most of what happens in their lives. Further, given that it's absurdly easy to get people to remember things, even of the extremely traumatic variety that never actually happened, trying to distinguish between real and false memories is something of an effort in futility without outside hard evidence. In the end, it turns out that human memory is incredibly fallible, but few of us want to accept that, so much of what we remember in life didn't quite happen, or in some cases, happen like we remember it. This, unfortunately, occasionally leads to people being convicted of sometimes even extreme crimes that they never actually committed.
Over the past 2 years, the SARS-CoV-2 virus, better known as COVID-19, has wreaked havoc around the globe, infecting more than 346 million people, causing 5.58 million deaths, and shutting down entire industries and nations, and also just completely changing our way of life. It's humbling to think that humanity has been brought to its knees by a pathogen so small it's dwarfed by most bacteria, and more humbling still when you consider that said pathogen might not even be alive. Unlike other disease-carrying agents like bacteria, protozoans, and fungi, viruses occupy a hazy region between life and non-life. Which side of the line they fall on depends entirely on who you ask. It is a fierce an ongoing debate, one which raises one of the most fundamental questions in biology. What even is life anyway? So, is a virus a life form? Let's dive in, shall we? To understand whether viruses are alive or not, we must first understand what a virus even is. While viral diseases like smallpox, rabies, polio, and influenza have been with us since the dawn of humanity, it's only very recently that scientists have come to understand the peculiar pathogens which cause them. Following the development of the germ theory of disease by Robert Koch, Louis Pasteur, and others in the mid-19th century, scientists embarked on a quest to hunt down and isolate the bacterial agents responsible for every known disease. Among these was tobacco mosaic disease, an affliction which stunts the growth of tobacco plants and causes their leaves to develop a mottled, mosaic-like pattern. In 1892, Russian botanist Dmitry Ivanovsky ground up the leaves of infected tobacco plants and passed the sap through a porcelain filter whose pores were too small to let even bacteria through. He then used the filtered sap to inoculate uninfected plants. To his surprise, the plants still developed the disease. Ivanovsky concluded that the disease was caused by some kind of chemical toxin which could pass through the filter, but he didn't pursue the matter any further. 6 years later, Dutch microbiologist Martinus Bering repeated Ivanovsky's experiments and confirmed his puzzling results. However, he also took the experiment a step further. After infecting one plant, Bering ground up its leaves, filtered the sap, and used it to infect another plant, and so on and so forth. If the infectious agent was a toxiny reason, then its potency would be reduced as it was diluted from plant to plant. But no matter how many times he transferred the disease, it remained as infectious as before. At first, Bering simply assumed that the infectious agent was simply an incredibly small bacterium, but no matter how hard he tried, he could not get it to grow on a nutrient medium, the standard method for culturing bacteria in the laboratory. It was also impervious to alcohol, which killed nearly all known bacteria. Stranger still, the agent, whatever it was, only seemed to grow and multiply in the presence of other dividing cells. Baffled as to what this agent could be, Bering dubbed it Contagium Vivium Fluidum, or contagious living fluid, and later filterable virus, after an old word meaning toxin. Over the following decade, scientists would discover many more viruses using the porcelain filter method, including a pathovirus, the cause of foot-and-mouth disease in 1898, and the yellow fever and rabies viruses in 1932. But the first major breakthrough in understanding what viruses actually were came in 1935, when American chemist Wendell Stanley determined that the tobacco mosaic virus was a particle, not a fluid, like Bering had hypothesized, and was composed entirely of protein. Stanley even managed to purify the virus particles into needle-like crystals, which could be stored indefinitely on the laboratory shelf without losing any of their infective potency. This discovery sent shockwaves through the scientific community, as a 1914 New York Times article reported, when Dr. Wendell Stanley of the Rockefeller Institute's Princeton station crystallized the virus which produces the mosaic disease of tobacco, there was a great hullabaloo among the biologists, and rightly so. Were these crystals alive? Apparently no more so than diamonds, glass, sand, or other crystals with which we are familiar. Yet when virus crystals were put on a tobacco leaf, the mosaic disease spread like a slow fire over the whole field, just as if it had been infected by living bacteria. Stanley's discovery, which won in the 1946 Nobel Prize in Chemistry, seemed to deal a death blow to the centuries-old doctrine of vitalism, which held that organisms contained some sort of vital essence or divine spark, which made them come alive. The chemical hypothesis of life, by contrast, held that life was simply a chemical process like any other, and Stanley's discovery that an apparently inert protein particle that could multiply and spread like a living organism seemed to confirm this. But many mysteries remained. In the same year as Stanley's discovery, the invention of the electron microscope allowed viruses to be directly observed for the first time and revealed why they had eluded microbiologists for so long. Most virus particles are on the order of 100 nanometers across. That's 10 to 100 times smaller than the average bacterium, and too small to be seen using a regular light microscope. But this did not explain how a mere protein particle could behave as though it were alive, yet be unable to grow in a laboratory environment. In 1926, American biologist Thomas Rivers proposed an explanation, stating in a presentation before the Society of American Bacteriology that viruses appear to be obligate parasites in the sense that their reproduction is dependent on living cells. In other words, viruses did not reproduce on their own via cell division like bacteria, protozoans, fungi, and other microorganisms, but instead, They hijack the molecular machinery of other living cells to produce more virus particles. But how did viruses accomplish this hijacking? As it turns out, a major piece of the puzzle was still missing. As later research by Wendell Stanley revealed, the tobacco mosaic virus was not in fact composed only of protein, but also of ribonucleic acid, or RNA. In the 1930s and 40s, a great scientific debate raged over the agent of heredity, which allowed genetic traits to be passed down from one generation of organisms to the next. While the laws of heredity had been discovered by Czech monk Gregor Mendel in the 1860s and refined by American biologists Thomas Hunt Morgan and Herman Muller in the 1910s, the specific molecule which encoded and transferred genetic information remained unknown. Some scientists suspected nucleic acids like RNA or its cousin deoxyribonucleic acid, or DNA, to be the agent of heredity. Most believed the more likely culprit to be proteins, which were far more complex than nucleic acids and could thus store more genetic information. Viruses would play a key role in determining which hypothesis was correct. In 1952, American bacteriologists Alfred Hershey and Martha Chase conducted a series of now classic experiments using T2 bacteriophages, viruses that infect the bacterium E. coli. At this point, it was known that viruses inject one part of themselves into the host cell, leaving the other part behind. But the question remained, was it the nucleic acid or the protein which was injected? To find out, Hershey and Chase first cultured a batch of viruses in a cell medium tagged with radioactive sulfur, which would only be incorporated into the protein of the virus. The next batch of viruses was cultured in radioactive phosphorus, which would only be incorporated into the nucleic acid. Both virus batches were then allowed to infect clean E. coli cells, and the resulting cultures spun in a centrifuge to separate the infected cells from the discarded, non-coding part of the viruses. When Hershey and Chase measured the radioactivity of the infected cells, they discovered that those tagged with phosphorus were radioactive, whilst those tagged with sulfur were not. This confirmed that it was the nucleic acids, not proteins, which the viruses injected into the cells. Subsequent work by scientists such as Rosalind Franklin, James Watson, and Francis Crick would go on to reveal the structure and function of DNA and RNA, starting a genetic revolution that's still shaping the world to this very day. Today, it's understood that all viruses consist of two basic components: a strand of nucleic acid like RNA or DNA encased in a protein coat or capsid, or as British biologist Sir Peter Meadowar eloquently put it, a piece of bad news wrapped up in a protein. Viruses come in all shapes and sizes, ranging from 27 nanometers for the porcine circovirus to 1.5 micrometers for pithavirus, and from long and tubular like the tobacco mosaic virus to spherical like coronaviruses. In addition to their protein coats, many viruses also incorporate a lipid envelope derived from their host cell membrane. The life cycle of the virus begins when it enters a host and makes contact with its cell membrane. If the cell is susceptible to said virus, then the virus latches on, and like a miniature syringe, it injects its genetic material along with a number of enzymes into the cell's cytoplasm, leaving the capsid behind. Once inside, the genetic material begins the nefarious process of taking over the cell's metabolic machinery and converting it from an independent organism into a tiny biological factory with a single purpose: to produce more virus particles. Viruses accomplish this hijacking in several different ways. In DNA viruses, the virus's genetic material takes the place of the cell's own DNA and uses the cell's own enzymes to transcribe this invasive genome into messenger RNA or mRNA. This mRNA is then read by cellular organelles known as ribosomes, which use its genetic instructions to assemble amino acids into proteins. Only instead of the regular proteins normally used by the cell to keep itself running, the ribosomes now produce components for new viruses. RNA viruses, on the other hand, contain mRNA that is directly read by the ribosomes, skipping the DNA transcription stage entirely. And yet a third variety of viruses, known as retroviruses, pull off an even neater genetic trick. Retroviruses, which include HIV, contain an enzyme called reverse transcriptase, which takes the virus's RNA and incorporates it into the host cell's own DNA. This embedded viral genome, known as a provirus, can remain dormant dormant within the host's genome for a long time, invisible to the immune system, and passed along from cell to cell as they divide and multiply. They can then spontaneously reactivate, causing the cells to start producing the virus again. This can make infection by retroviruses very difficult to combat. But the importance of retroviruses goes far beyond human disease. A full 8% of the human genome consists of proviruses acquired throughout our long evolutionary history. And as we shall see, these genetic hitchhikers have had a significant and underappreciated impact on the development of life on Earth. Once the new virus particles are assembled, they must then escape the host cell. For many viruses that infect bacteria and other single-celled organisms, this is accomplished via the lytic cycle, in which the cell membrane is ruptured or lysed, killing the host cell and releasing the new generation of viruses into the environment. However, as killing every cell a virus encounters would quickly lead to the death of the host and the viruses with it, most viruses instead exit the cell via either ectocytosis or budding, passing through the cell membrane without rupturing it. But whatever the process, the end result is the same. The newly assembled viruses are released into the environment, ready to infect new cells and start the whole process over again. Now that we know what viruses are and how they reproduce, let us return to the original question. Are viruses actually alive? The answer, as with so much in biology, depends on how exactly one defines life. Unique among the sciences, there is no firm consensus within biology as to what exactly it is that biologists actually study. While at first glance, the question of whether something is alive or not might seem straightforward, throughout history, a concrete, testable definition of life has eluded even the greatest scientific and philosophical minds, with the common consensus essentially boiling down to, well, we know it when we see it. But as the lack of such a definition did not prevent biologists from carrying on with their work, for many years the subject remained a mere philosophical curiosity. However, as humanity began to explore the cosmos and search for life on other planets, the question, what is life, suddenly became a much greater priority. Over the years, various scientists have attempted to draw up lists of properties unique to living organisms, such as this one from the NASA website. Living organisms have the ability to take in energy from the environment and transform it for growth and reproduction. Organisms tend toward homeostasis, an equilibrium of parameters that define their internal environment. Living creatures respond, and their stimulation fosters a reaction like motion, recoil, and in advanced forms, learning. Life is reproductive, as some kind of copying is needed for evolution to take hold through a population's mutation and natural selection. To grow and develop, living creatures need foremost to be consumers, since growth includes changing biomass, creating new individuals, and the shedding of waste. However, many of these properties are also exhibited by non-living systems. Crystals, for example, can spontaneously organize into incredibly complex and ordered shapes, self-replicate, and transfer this internal order from crystal to crystal, even more in response to external stimuli. Similarly, a dark stone can convert solar energy into thermal energy and then into kinetic energy by heating the air around it, while radioactive elements can spontaneously turn nuclear energy into thermal energy. This definition even breaks down when applied to certain biological systems. For example, prions, the agents responsible for bovine spongiform encephalopathy, better known as mad cow disease, are even simpler than viruses, consisting of rogue, misfolded proteins devoid of any genetic information. Nonetheless, prions can mutate, spread from host to host, and multiply, though not by passing on genetic information, but rather by causing adjacent proteins to misfold in a deadly chain reaction. And for more on this, please check out our previous video, The Gruesome Tale of the Laughing Death Epidemic. A more sophisticated set of properties unique to living organisms was set forth by Austrian physicist Erwin Schrödinger, best known for putting hypothetical cats in hypothetical boxes. Same dude. In his 1944 book, What is Life?, Schrödinger remarked upon, quote, an organism's astonishing gift of controlling a stream of order on itself and thus escaping the decay into atomic chaos. In other words, living organisms appear to defy the second law of thermodynamics, which states that in a closed system, entropy, variously defined as disorder or energy which cannot be used to perform useful work, always increases. In the face of natural forces which are constantly trending towards greater disorder, organisms not only manage to maintain a high degree of internal order and complexity, but to maintain said order over multiple generations with very little loss of fidelity. Of course, organisms do not actually violate the second law since they are not closed systems. Rather, they are semi-bounded systems, closed off enough from the outside world to maintain internal order, but permeable enough to allow this increase in order to be counterbalanced by a decrease in order outside the organism, for example, through the release of waste heat. Nonetheless, these observations allowed Schrödinger to postulate that such a semi-bounded structure was essential to the functioning of living organisms. More importantly, he further postulated that in order to accurately transfer their internal order and complexity to subsequent generations, organisms required some form of code script containing instructions for building that particular organism. This prescient prediction would, of course, be vindicated less than a decade later by the discovery of the structure and function of DNA. In the wake of Schrödinger, scientists like British biologist John Maynard Smith suggested that the fundamental property of life was its ability to undergo Darwinian natural selection, in which heritable traits which increase an organism's reproductive capacity are selected for and preferentially passed on to subsequent generations, allowing species to gradually evolve over time. Eventually, this notion was combined with previous definitions to produce the so-called NASA definition of life, which states that, quote, life is a self-sustained chemical system capable of undergoing Darwinian evolution. On the second count, viruses certainly fit the bill, as the rapid mutation of COVID-19 into multiple variants clearly demonstrates. But it is on the first part of the definition that the argument for viruses being alive stumbles. For unlike other organisms, viruses are unable to replicate in the absence of other living cells. Without a host cell's molecular machinery to hijack, a virus is just an inert bit of protein and genetic material. Thus, according to Gerald Joyce of the Salk Institute, quote, according to the working definition, a virus doesn't make the cut. But for not being alive, viruses certainly play an outsized role in the natural environment. While it is impossible to know for sure, biologists estimate that there are some 10 to the power of 31 viruses in the world. That's a number so mind-bogglingly large that if laid end to end, these viruses would stretch some 200 million light years, well past some of the farthest known galaxies. Viruses are found in every environment on Earth and infect every known organism, though the vast majority are benign and do not cause harmful illnesses. Nonetheless, they have a tremendous impact on the evolution of life on Earth, particularly via the reverse transcription of viral genes into the host's DNA. For example, blood oranges exist thanks to a viral gene called TCS2, which in response to cold weather switches on a gene called ruby that gives the fruit its distinctive deep red hue. Closer to home, an ancient viral gene called ERVW1 is responsible for the development of a fused cell structure in the human placenta called a syncyte eotrophoblast. Wow. Which is vital for the transfer of nutrients to the developing embryo. Thus, all of us owe our very existence to a virus that infected an African ape millions of years ago. For this and other reasons, certain scientists believe the NASA definition of life is overly narrow and should be expanded to include borderline cases like viruses. Among these is French microbiologist Patrick Forterre of the Pasteur Institute, who argues that, quote, life and living processes are simply names for complex, evolving forms of matter that are now present on our planet. Forterre conceives of viruses not simply as assemblies of protein and nucleic acids, but as organisms with two distinct phases in their life cycles. The inert virion, or virus particle, and the virocell, the living cell, which has been taken over by the virion and converted to producing more virions. In Forterre's model, the virocell is contrasted with the ribocell, the regular, healthy form of the host cell, the difference between the two being, whereas the dream of a normal cell is to produce 2 cells, the dream of a virocell is to produce 100 or more virocells. Thus, according to Forterre, the virion is to the virocell what a seed is to an oak tree, and viruses are no different from any other parasite that depends upon its host to grow and reproduce. They are simply more dependent than most. Other scientists argue that any attempt to rigorously define life is inherently unproductive, as it might prevent us from recognizing as yet undiscovered exotic forms of life on Earth or other planets. As Carol Cleland, a philosopher philosopher of science at the University of Colorado, explains, definitions tell us about the meanings of words in our language as opposed to telling us about the nature of the world. In the case of life, scientists are interested in the nature of life. They are not interested in what the word life happens to mean in our language. What we really need to focus on is coming up with an adequately general theory of living systems as opposed to a definition of life. Despite its amazing morphological diversity, terrestrial life represents only a single case. The key to formulating a general theory of living systems is to explore alternative possibilities for life. I'm interested in formulating a strategy for searching for extraterrestrial life that allows one to push the boundaries of our Earth-centric concepts of life. On the other hand, I don't think that defining life is a very useful activity for scientists to pursue, since it is not going to tell us what we really want to know, which is, what is life? A scientific theory of life will be able to answer these questions in a satisfying way and do the same for fringe cases. Merely defining life in such a way that it incorporates one's favorite non-traditional living entity does not at all advance this project. And so the debate rages on, with nearly every biologist being firmly convinced that the matter has already been settled in one way or another. All we can say for sure is that given their impact on the past, the present, and the future of life on Earth, alive or not, viruses deserve nothing but our utmost admiration and respect.
Most couch potatoes have probably at some point in their lives said, "I can't run a kilometer without feeling like I'm going to die." They might also sarcastically proclaim they must be allergic to exercise. And amazingly enough, it turns out there is a rare disorder in which someone can be deathly allergic to exercise, a condition known as exercise-induced anaphylaxis, or EIA. Allergies in general come with a wide range of symptoms and can range from mild to very, very deadly. Fortunately for most, a deadly allergic reaction known as anaphylaxis is rare. It's generally accepted anaphylaxis affects approximately 2% of the population, and EIA is thought to represent only about 5 to 15% of all of those anaphylactic cases. Interestingly, of those, women seem to be twice as likely to suffer from it than men. It's important to note that although the symptoms of anaphylaxis can be brought on by exercise, exercise itself might not be the only cause of the reaction. Typical allergy mediators like foods, pollens, and medications, when combined with exercise, may result in such a reaction. Among these, food-dependent exercise-induced anaphylaxis is the most common, accounting for 1/3 to 1/2 of all EIA cases. In essence, your body can handle the offending food and it can handle the exercise, but when you combine them, you get an overreaction of your immune system. So, now the big question is, well, what exactly is going on here? So, our immune system is extremely complicated and it requires numerous types of cells and molecules working together to fight off a foreign pathogen. Any reaction from your immune system is generally divided into two different categories: innate and adaptive, both of which have specific types of cells working in response to an infection. All of these cells are broadly classified as white blood cells. An innate immune system reaction uses cells that can recognize several different types of foreign invaders, pathogens like viruses, bacteria, and fungi. It can be activated by some non-infectious problems, like simply being exposed to cold or hot temperatures, and even just pumping some iron. The specific types of innate immune system cells include basophils, eosinophils, neutrophils, monocytes, and mast cells. Adaptive immune cells, on the other hand, react to specific pathogens, usually produced by your lymphatic system. They're known as B and T cells. While they work differently, both B and T cells have the same goal, and that's to defend the body against specific types of invaders. Your immune system can make T and B cells that match the surface molecules of invading pathogens, with the T and B cells able to quickly multiply, producing large numbers of identical cells that can recognize and destroy the foe. These cells do not directly attack infected cells. Rather, they primarily produce antibodies, unique protein molecules that attach to specific harmful pathogens. These are called antigens. This antibody acts like a red flag to T cells and other disease killers known as phagocytes. These are then able to recognize the foreign body and destroy it. Once the infection disappears, memory B cells can stay around for years, sometimes throughout your entire life. If the same invader appears in the future, it will once again mobilize and attack the pathogen. Produced by your thymus, thus T cells come in several different types and perform different functions. Helper T cells produce chemicals triggering B cells to develop into plasma cells. Killer T cells target and kill cells that have become infected or are cancerous. Regulatory T cells help control your immune system's reaction, preventing it from getting out of hand. Memory T cells, like memory B cells, stick around for a while, quickly reacting should the same invader appear. When your immune system reacts to an allergy, it can present with symptoms ranging from mild to, life-threatening. The more common, less problematic symptoms are things like fever, cough, runny nose, itchiness, hives, and general body aches. These mild symptoms usually don't require a visit to a doctor, and if annoying enough, you might treat it with over-the-counter medications like Benadryl. Should your immune reaction continue or become out of control, it can progress to anaphylaxis. Generally accepted as life-threatening, this reaction is more systemic and involves several organs and body systems. It can produce more serious symptoms like nausea, vomiting, abdominal pain, and dizziness. It can also result in difficulty breathing from swelling to the face, throat, and the lungs. Your veins and arteries also might begin dilating to the point that your blood pressure becomes extremely low and you actually pass out. All of this can progress to rapid heart rates, cardiac dysrhythmias, and even cardiac arrest. So, anaphylaxis, or any lesser immune response caused by exercise, isn't different from any other anaphylactic reaction. It was first reported in the Journal of Allergy and Clinical Immunology in June of 1979. The authors described a case where a patient had an anaphylactic reaction to shellfish, but the reaction didn't occur until the patient went for a run. The authors further noted that the allergic reaction was only mild and well tolerated when the patient ate shellfish without exercise. If he didn't eat shellfish, he could run without issue. When combined, however, the patient would have an anaphylactic reaction. Since this 1979 report, there have been numerous accounts of patients who have had anaphylactic reactions from exercise, including recognizing the link between food and other allergies when combined with exercise, as previously mentioned, with food-dependent seemingly the most common. To be specifically diagnosed with EIA, you need to have symptoms of anaphylaxis associated with exercise. The cause must also be differentiated from an anaphylactic reaction due to food-dependent anaphylaxis or being exposed to an allergen before the workout. It should also be noted that EIA can be brought on by things that some people might not consider strenuous, like a mild stroll in the park, though it's much more commonly seen when a more strenuous workout is pursued. Interestingly enough here, the reaction is also not always repeatable. The same exercise causing it today might not actually cause it tomorrow. Well, this all brings us back around to what exactly is going on in the body in order to cause this. While the specific factor or factors producing exercise-induced anaphylaxis aren't proven, it's generally agreed among researchers that histamine release is the key component in the reaction here. Histamine is known as an autocoid, which acts like a hormone, only it has a more localized reaction. It's released from the innate immune system cells, basophils, and mast cells. The process is called degranulation. Once secreted, histamine helps increase the absorption of allergens to the body's organs, like the skin. Once there, other mast cells get stimulated to degranulate by an antibody, immunoglobulin isotope, known as IgE. IgE attached to mast cells has long been known to signify an acute allergic reaction. The acceptance of histamine being the mediator in EIA comes from the fact that there is an increase in plasma histamine, along with the IgE being present on mast cells within the skin in patients experiencing EIA. These patients also tend to be more susceptible to degranulation of their mast cells and their basophils compared to people who don't have EIA. The reason for this lowered threshold and the exercise-specific reason for degranulation producing histamine hasn't actually been proven. There are some widely accepted theories, however. They include increased gastrointestinal permeability, absorption, blood flow redistribution, increased osmolality, and increased endogenous endorphin release. Well, that was a bunch of long words, so let me put this in slightly more layman's terms. Exercise induces the absorption of nutrients and other molecules from the GI tract. The speculation then is that the allergens will have greater contact with the parts of the immune system associated with the gut, which happens to be a lymphoid organ. This is probably nature's way of protecting us from the many potential pathogens that we put in our mouths. As for blood flow redistribution, this is thought to contribute because during exercise it's redirected from inactive tissues like those found in your digestive tract to active tissues like those found in your skeletal and muscle tissues. Those tissues' mast cells are different from the ones found in your GI tract. Therefore, the thinking is that as long as a food allergen remains in the gut and only exposed to those type of mast cells, it doesn't cause histamine release. But should it go to the skeletal muscles and skin, those mast cells will degranulate and cause a reaction. Exercise also causes the release of endorphins, which gives you the same type of feeling that taking morphine would give you. The release of these endorphins has been known to enhance mast cell degranulation. It seems reasonable then that the aftermath of this increased endorphin release would escalate the degranulation of mast cells, resulting in a histamine response that causes the cascading effects of anaphylaxis. This brings us to the final forerunner in the theories of why certain people get EIA, involving increased osmolality in your intestines. This means there is more allergen getting to certain areas of your intestines, specifically the worm-like processes called villi in your small intestines. It's thought that when you exercise, the mast cells at the bases of your villi get exposed to more of an allergen. This exposure then secretes histamine, which in turn results in an increased distribution of the allergen to many of the body's organs, such as skin, and the cascading effects of histamine then produce anaphylaxis. No matter the exact cause, the treatment for EIA is the same as any other anaphylaxis. Avoid repeating the same behaviors that caused a reaction in the first place. As any good doctor would say, well, if it hurts to do that, stop doing that. For those who want to do that anyway, recent evidence has suggested that pre-treating people with agents that inhibit cell degranulation may prevent food-dependent EIA. Should you unsuccessfully avoid experiencing anaphylaxis, well, I'd recommend you call for emergency medical aid. The doctor or paramedic will treat the life-threatening symptoms first, like the swelling in your respiratory tract and your extremely low blood pressure. They will then attempt to prevent the histamine cascade of death with antihistamines like Benadryl and corticosteroids like prednisone. In the end, yes, a person can be allergic to exercise, but as it's an exceptionally rare condition, should your body mass index be higher than your age, you probably aren't one of those who can use it as an excuse not to hit the gym.